If you are someone who's looking to get into AI product management, then this is a must-watch video for you. Few days ago, I conducted a free masterclass for about 500 people who joined this session, and then they were able to understand how AI product management is done. Now I've decided to make this video available for everyone so that everyone can take the benefit. My only request is that before you go ahead and start watching this video, keep a notebook and pen with you so that you are able to take notes and have your full attention in the session. I'm sure this is going to help you out. And if it helps, go ahead and let me know in the comments. Thank you and happy learning. So we have divided this 2-day masterclass into 3 components. The first component is GenAI Fundamentals, where we'll talk about the GenAI value stack, types of AIPM, and nature of large language models. Then we will talk about inside AIPM. We'll talk about context engineering, RAG, prompt engineering, fine-tuning, AI agents, and AI evals. Even if you're not able to understand anything right now, it is my promise that by the end of tomorrow, you should be able to understand these topics. And then we are going to talk about giving you actual examples, how products such as Chat, PRD, Granular, Gamma AI, Notebook LM are actually built. Right? So this is going to be the session agenda for these 2 days. And the motivation or the purpose of this session is not to make you an expert in AI product management, because that cannot happen in 4 hours. But the motivation of this session is to make sure that you feel motivated after completing these sessions, that yes, I have a clear roadmap. If I can learn this much, I can also go ahead and learn and explore the entirety of AI product management. So this is to give you the confidence so that you are able to get started. Right? And tomorrow and today, and in today's session, I'm going to ask you in the end that whether you are feeling motivated after the session or not. Right? Now, let's talk about the Gen AI revolution. Right? The companies that you are seeing on the screen, they are now among the world's most valuable companies. And many of these companies have been able to get this kind of amazing transition just after 2022. So from 2022 to 2023, this company OpenAI has got a valuation of 500 billion. This Anthropic company, which was not existing a few years ago, now has a valuation of $183 billion. And then we have something called as XAI, Elon Musk's company, which has the valuation of $200 billion. Not only the new companies are doing well, but the older companies which are betting on AI as a revolution, which is Microsoft has gone from, so Microsoft was founded in, Microsoft was founded in about 1980s, 1983. And from there to 2021, they were able to get a market cap of 1.8 trillion. But in the last 3 years, they have grown from 1.8 to 3.8, almost twice the increase. Similarly, Google, after betting on AI, they have grown their valuation almost 2.5x. Similarly, Meta has grown too much from 0.3 billion or 300 billion to 1.8 trillion. And then Nvidia, which is the company which has most benefited from this AI revolution, it has gone almost 10x of their valuation. Right? And then we have also seen some very new age companies which are actually created in this period only. So Cursor, the company did not exist a few years ago, is now worth $9 billion. Gleam is worth $7 billion. 11 Labs is worth $6 billion. And Perplexity is worth $15 billion. So now there is a sharp change that has happened in the market recently, because of which people are able to understand that there is this new technology called GenAI, which can go ahead and do so many things together. Okay, but understand, as many people have predicted, this can well be a bubble. So how do you check if something is a bubble or not? It might be possible that all of these companies are overvalued in some or the other way. But let me ask you a very honest question. Okay, everyone, go ahead and answer me in the chat. When was the last time that you have used ChatGPT and Gemini? Yeah, I'm sure for many of you, your one of the tab is ChatGPT right now. Yes, cool. right? So understand, there have been many technologies that have came and gone. For example, there was a revolution on blockchain, there was a revolution on cryptocurrency, there was a revolution on NFTs. Although you were listening about all of these things on news, on multiple websites and Twitter, but they could not become a part of your daily life, right? So the verdict is that it might be possible that these things that we are talking about, the valuation and all, these could be larger than life valuation. That is completely possible. I'm not disagreeing with that. But we also have to understand that Gen AI is a technology that has been able to prove itself that it is actually very helpful. Because technology, if it is only increasing the valuation, that might mean that yes, it could be a bubble. But if it is genuinely helping you in your daily life, then it just means that it is just a matter of time that we are able to find its relevant use cases and utilize it for work and more of our personal life. Right? But how has it happened? Like, what is there in the Gen AI revolution? So understand, the Gen AI revolution has happened because of an innovation in technology, which is called as large language model. Okay. So what is a large language model? A large language model, a large language model is a neural network trained on massive amounts of text to learn patterns in language, enabling it to understand, generate, and reason with natural language by predicting the next most likely word or token in the context. Right? This is the Wikipedia definition of large language models. But what exactly is a large language model? Let me go ahead and tell you. Please, everyone, focus on the session. Super important part. Yes. So we are talking about large language model. So a large language model it is kind of a code or an algorithm. It is kind of a code or algorithm or a piece of technology that is very good at predicting the next word in the sequence. That is very good in predicting the next word of the sequence. Right? For example, I just take this sentence. I will take this sentence. I will increase the size. Right? So let's say if I enter this particular thing to a large language model, if I tell a large language model that a large language model is then it is going to return me neural. It is going to return to me the next word. If I give it a complete sentence that a large language model is a neural, then it is going to return me network. And then I will keep on iterating so that I'm able to get the complete sentence. So what is a large language model? Large language model is the next word or token predictor. And when you do this repeated number of times, you get the complete sentence, the complete book, the complete essay, the complete summary. Right? So this is the basic fundamental how a large language model works. You give it some sentence, incomplete sentences, it will try to complete it. And how does it complete it? Let me go ahead and tell you. Okay, so understand, first of all, if you guys are able to observe, I have written token in the bracket. So what happens is, whenever you give a word to a large language model, okay, so let's say I give a word to language model that he lives near the river bank. He lives near the river bank. Okay. So large language model is a machine. It's an algorithm. It's a code. It will not be able to understand what are these exact words. In order to make sure that the machine is able to understand everything, what we do is we convert this into numbers. So in order to make sure that the machine is able to understand things efficiently, we convert these into numbers. These numbers are called as tokens. Let me show you how it works. So I'll go to a website called as Tick Tokenizer, where if I write this sentence, the sentence is, he lives near the river bank, right? Now, the large language model has converted this. The large language model has converted this into these tokens. So these are the tokens, right? Every model can generate different kind of tokens. Every model has different kind of combination of tokens. Okay, the tokens are generated to make sure that the large language model is able to efficiently utilize its memory and context, because numbers are easier to interpret for machines rather than the words, right? And in total, in English language, we have around 26 alphabets, and we would have so many, maybe millions of applications, millions of spellings, right? Vocabulary. In GPT-4, we have 100K tokens, right? So what is a token? Token is a numerical representation of your text. Token is a numerical representation of your text, right? And at a high level, 3 words in English is equal to, sorry, at a high level in English, 2 words are equal to 3 tokens. At a high level, like, not, this is not completely true in all the cases, but for most of the times, on an average, 2 words is equal to 3 tokens. Why tokens are important? So understand, if you go to any of these applications, let's say, let's understand OpenAI pricing. So if you look at pricing of any of these models, you'll be able to understand that they work on tokens. How many tokens are input, how many tokens are generated, how many tokens are cached, right? So for every 1 million tokens that you give to ChatGPT, it is going to ask you for the input. It is going to take $1.25 from you, right? So what is a token? Token is a conversion of your words into mathematical numbers so that the model is able to understand them very, very efficiently, right? How many tokens are possible in a model is called as the vocabulary size of the model. How many tokens are possible in a model is called as the vocabulary size of the model, right? So this is called as the tokenization, right? Now what happens? The purpose of an LLM is that if you give it a set of tokens, let's say 1, 2, 3, 4, 5, it will try to predict what is the next token. Then if you run it again, then this becomes your full sentence up to 6, then it will generate 7. And then you have new sentence 1 to 7, and then it will generate 8. So it is going to go ahead and complete the sequence, right? That is at the most fundamental level how large language models work, right? Everyone, a quick yes or no if you are able to understand everything so far. A quick yes or no before I could go ahead. Wonderful, great. Now let me go ahead. But this is a simple explanation. But how does it happen? How does it predicts? Okay. So what happens is, this is how a large language model works. Okay. So there are 3 stages. Whenever we create a large language model, we use these 3 stages. Every large language model is created by going through these 3 stages. The first stage is called as a pre-training stage. The second stage is called as the training stage. And the third training is called as a post-training stage, right? So in the pre-training state, understand what happens is, the models are able to predict the next token very accurately because they are very good with pattern recognition. So what we do is, we need to train this model on a lot of data. We need to train these models on a lot of data. Okay. But before that, let me help you understand why this data is necessary. Okay. So how many of you can tell me what is this? Tell me in the chat, what is this? Guys, go ahead and tell me in the chat, what is this? Wonderful. That means you guys have studies uh, in the elementary mathematical classes, right? So y equal to mxc is nothing. It is a very simple equation. It is the equation of a line, any straight line. This is y-axis, this is x-axis, this is the slope, and maybe this is the intercept. Right? So this is a simple equation. That is y equal to mx plus c. Right? Now, if I want to know what is the value of y at this value of x, if I want to know what is the value of y at this value of x, so x is the input and y is the output. So now if I want to know what is the value of x at this, what is the point of y at this value of x, because there are two things right now I might not be able to understand. Because there are two parameters which are unknown to me, I will not be able to understand. But what if I already know two values of input and two values of output? So let's say somehow I was able to find that if x barabar 1, if x is equal to 1, then y is equal to 2. And when x is equal to 0, then y is equal to 1. Right? So let's say somehow it is given to me that this is true. This is called as training data. Training data is something where the output and the input is known to me. Right? Now what I'll do is, I will try to find out the value of m and c. So y is equal to mx plus c. I'll put the value of x and I'll put the value of y. So 2 is equal to 1 into m plus c. 2 equal to m plus c. So c is equal to 2 minus m. Right? I also have the second value. So what I'll do is, y is equal to mx plus c. That means 1 is equal to m into 0 plus c. C is equal to 1. Right? Now c is equal to 1 and c is equal to 2 minus m, which means m is equal to 2 minus c. 2 minus 1 is equal to 1. So c is equal to 1 and m equal to 1. Now the equation becomes, I have found all the parameters. I was able to find the value of m. I was able to find the value of c. So c is 1 and m is also 1. So the equation is y equal to x plus 1. Now you give me any kind of input in the world, give me any kind of output in the world, give me any kind of input in the world, and I'll be able to tell you what is going to be the output. Right? You give me any kind of input in the world and I'll be able to give you the output. Right? Now, if you go ahead and amplify the same thing, if you go ahead and amplify the same concept to billion number of times. So now what happens is, a large language model is an equation like this, but it contains almost greater than a billion parameters. Right? So in order to find two value of parameters m and c, I needed to have two values of input and output, also called as training data. Training data that I already know. Right? In the case of a large language model is nothing. It is a very complicated mathematical equation, plus the equation contains a lot of parameters. How many parameters? Maybe billions of parameters. Right? So in order to determine these parameters, what I need to do? I need to have billions of training data, which is I need to have large training data. Right? And then this is repeated multiple number of times to get the values of these parameters. So how do we get this training data? We get this training data from the pre-training. So before we train any model, what we do is we crawl the internet. We look at the forums. We take the books that are written already, literature, well-written books. And then we convert this data, we clean this data, and then we train on this data. How do we train? How do we train on this data? Understand, any piece of text that you have, that piece of text can be converted into two parts: the input and the output. For example, let's say in the training data, I was able to get this. So I have written a blog around AI ML product management. Okay. So let's say I have this sentence. So I will collect a lot of data. I will break down this data into small parts so that I'm able to feed it to the large language model. And then what I'll do is, let's say one of the training data is this. One of the training data is this. So what I'll do is, I know that this sentence is correct. So what I'll do is, I will just feed this part. I will feed this part as the input and this part as the output. Because what does a large language model does? If you go ahead and give it any sentence, it will try to complete it. So I'll give multiple billions of rows and billions of, let's say, components of data in the form of input and output. And when the large language model will learn, it will learn from these patterns, and then it will be able to give you almost real kind of reasoned answers. Right? A quick yes or no, everyone, if you are able to understand this. I have tried to help you understand large language models with the help of a very simplistic linear equation. Yes? Cool. Now let's go ahead. Yes. Cool. Now we have understood this. Now let me go ahead and take you one step ahead. Okay. So now everyone, please look at this very carefully. So how does a model trains itself? What happens is, this is what the structure is. You have the training data. In the training data, let's say you have this sentence. You are going to break this sentence into two parts. One part is this, the initial part of the sentence. Other part is this, the later part of the sentence. The initial part of the sentence is the input, and the later part of the sentence is the output. So ideally what you want is, you want the model to behave in a way that whenever you write how LLMs, it should complete with work. Okay, this is what you want. So what you will do is, you will break the sentence. This is one sentence, this other sentence. You are going to tokenize it. Tokenize as in you are going to convert it into maybe some kind of numbers. Okay. And every model that you are running, they would have their own method. So there are some free and available APIs available through which you can go ahead and tokenize your content into any kind of numbers. Okay. So we have done the tokenization. Now, whatever are the input tokens for how LLMs are going to be feed as an input, right? And the output token is going to be here. I'll tell you how it is going to work, right? So now it will be feed into a large language model. Okay. A large language model is a specific kind of, I would say, right now we are talking about a large language model, which is a neural network, and the type of the neural network is transformer. I'll talk about what a transformer is in brief in tomorrow's session. Okay. So a transformer, what is a transformer? It is nothing but a mathematical expression, a long mathematical expression. Understand it 1,000 times more complicated than the line equation that I have given you. And it contains the parameters, the constant that I have told you. Right. And the purpose of this large language model training is to identify the value of these parameters, to identify the value of M, C, and other parameters that it has. It can have billions of parameters, right? Now, what will happen? It will initially, when it is not trained, it will try to generate anything random. Okay, and also understand one thing, that the large language models are not deterministic. Listen to this very carefully. This is super important to understand the language of large language models. I told you that they are next token predictors. Predictors means they will not tell you that this is a token after this. They will give you some probabilities. So he is this is the input, and the large language model is going to give you probabilistic outputs. So it is going to give you many options. It will tell you he is a man, he is a boy, he is a father, he is a singer. So there are multiple probabilities, right? And then it is also going to tell you, the large language model, that what is the probability. So let's say man, the probability is 0.5. Boy, the probability is 0.4. Father, probability is 0.05. Singer, probability is 0.05. Right? So it will not tell you the one answer. It will not just give you one answer. It will give you the probabilities of what other words could be there. And then you can go ahead and choose the top word or second word, whatever your large language model can go ahead and pick up. Okay. So always remember, the large language models are not deterministic. They are stochastic, which means they can go ahead and pick random words, which are going to be correct in some context. But if you go ahead and give same prompt to same model at the same time, it can go ahead and give you different kind of outputs. Right? So this is important nature of an LLM to know. And this is also going to be a foundation of when we go ahead and learn about AI evaluations. Right? And how does it generate this? It generates on the basis of training. So it would have seen a lot of data, and based on that data, it generates that, yes, I think this should be the probability based on what I have learned. Right? Yes. Cool. Now, going back to a diagram. So what will happen here is, what we have done so far is, we have done the tokenization. We have taken the input part. We have fed it into a transformer. The transformer has generated some random results. And then what will happen? We have the real actual token. The actual token is going to be the meaning of work, like the numerical token for work. Okay. And here it is going to generate something. Now it will be compared that work should have a probability of 1, or work should be at the top of the predicted numbers or the predictive tokens. And then we are going to calculate the difference. That it should be work, but it is not work. So it is going to share this feedback with the transformer. And then what transformer will do is, transformer will correct the parameters inside. And then this model will run on multiple training sets for billions and trillions of time. And then you are going to go ahead and get a model that is going to accurately predict what should be the next probable word. Right? So what we do is, we give it the training model, we have the output, we have the input. Then we check the difference between the real output and the expected output. Right? Then we calculate the difference, which is called as a loss function, which is called as a mathematical loss function. This is passed as the feedback to the large language model. And then when it keeps on doing this billion number of times, it is able to set a very accurate value of these parameters. Right? If you run it n number of times, you will have a pretty accurate model or a large language model. Right? Understand, if the number of parameters are in a race of billions, this is called as a large language model. If it is less than billions, maybe in the ratio of millions, it will be called as a small language model. Example of a large language model is Gemini, Chat GPT, example of a small language model is Google's Gemma. Right? Yes. Quickly, everyone, a quick yes or no in the chat if you are able to understand this, at least at a high level. Wonderful. Great. You guys are intelligent. Great. Amazing. So loss function understands the difference between what is the predicted token and what is the actual token, and then it pass on this feedback to the transformer. The transformer adjusts everything accordingly. Right? Now, a bigger question that should arise in your mind is that why all of these things are happening after 2021? Like, why all of these things are happening very recently? Why not before? Okay. So understanding language is not an easy task for machines. Why? Because of this reason. So let's say my sentence is, he lives near the river bank. Right? Traditionally, what people used to do was, if they want to create any kind of AI, if they want to create any kind of predictive model or intelligent model, what they will do is, they will work on word by word. You might have seen autocorrect in your mobile phones, right? Whenever you try to write something, it will only catch the last word, and then based on it, it is going to predict. It will not look at the entire sentence. Okay. But people were able to understand, people who understand NLP or natural language processing or programming, they were able to understand that it's not enough. They were able to understand that if we want to really understand language, we need to understand the meaning of each word with respect to that sentence. For example, in this particular sentence, I have written, he lives near the river bank. So in this, bank means the side of the river, right? But if I did not know this sentence, I could have as well concluded that this bank is a financial institution. So in 2017, a group of computer researchers created a research paper, published a research paper. They all were working in the Google Brain and DeepMind team. And the name of the paper was Attention is All You Need. And they came up with the hypothesis that if we really want to truly understand language models, if we truly want to understand the language, rather than looking at things token by token, we should try to find out what are the relationships of these words with entirety of the sentence. Initially, these predictive models can only look at one word at a time. But now with this approach, we were able to go ahead and consume all the sentences and essays and whatever is the context window at once. So every word is now able to map its relationship with other words. So these words are created into tokens and vectors, and then the relationship between all the vectors is calculated real time. And then as a whole, we are able to understand what does this paragraph, what does this sentence, what does this context says. That was a very big shift of how GenAI was born. Okay, but now because of that, one problem occurred. The problem was the sequential processing of data was easy. It can be done on a CPU. But if you need to process multiple sentences, multiple parts of the sentences at once, understand, when I'm talking about the sentence, he lives near the river bank. At once, the algorithm or the computer has to calculate this relationship of he with lives, with near, with the, with river, with bank. Then parallelly, it needs to understand the relationship of lives with he near the river bank. And then it also needs to understand the relationship of this with this. So now understand, this is complicated maths. This is resource intensive maths. Resource intensive maths. It will take time, it will take effort, it will take a lot of processing power. Right? So in order to create a good, solid large language model, you need two things. First, you need a lot of data on which you can train so that AI is able to find patterns. Plus, you need super huge processing power. And now people started thinking, where do we get this processing power from? Because quantum computers are not yet invented, at least at the scale for practical purposes, and CPUs are very much limited. Then people thought that these kind of metric multiplication, like one-to-many multiplication, also happen at games. And games are running on GPUs. So people understood that, yes, transformer is an architecture. So the neural networks or the algorithms that operate in this way by calculating the relationship of one word with every other word, these kind of algorithms are called as transformers. They work on the mechanism of attention, which is one word is paying attention to every other word in the sentence. Attention means one word is paying attention to every other word in the sentence to derive its meaning. Right? And then the neural networks or the algorithms that use attention as a mechanism to predict are called as transformers. Right? And transformers are best run on the same technology that runs these complicated games, which is GPUs. Right? So this is a history about how GPUs were best suited for running large language models. And that is also the reason why we were able to get a huge jump here. We were able to get a huge jump here. Right? Everyone, a quick yes or no if you are able to understand this. Yes. If I see one more LinkedIn link in the chat, I am going to block you. Don't distract other guys, please. Yes. So large language models run on GPUs. They are trained on GPUs. Right? Now, so we have understood this. Now let's go ahead. Okay. Now the third part. I have told you about the two parts already. The third interesting part of a large language model. So we have talked about pre-training. We have talked about pre-training. We have talked about training. Now the third part is post-training. Now after you train a large language model on all the internet data that is available, you get a personality like a baby. A baby has the ability to think. It has the ability to perceive its surroundings, and they will also be able to go ahead and maybe blabber a few words, right? But they don't have a personality yet. So depending upon a baby is born in a Hindu family or a Muslim family or in a particular culture, they are going to get their nature. So if you are reading Quran, you are going to think this is the God. If you are going to read maybe Gita, you are going to understand that maybe this is the God. Okay, reality could be something else altogether. But based on how you are conditioned, based on how you are trained after you are in the world, that is called as post-training. That gives you a personality. So post-training is very important. It converts the next token predictor machine to a helpful assistant. It converts the next token predictor machine to a helpful assistant. Right? So what we do is we hire real human laborers, like what do we call it? People who go ahead and label the data. So these people give accurate information to the large language models. And then this data is feed again into the training. And then the large language model gets a personality. For example, there is one thing that large language models have struggled for a long period of time. Okay. So large language models generally tend to hallucinate. Although the hallucination has reduced very, very recently, but still there is, let's say, a lot of hallucination still. Okay. So Meta came up with this very interesting perspective. What they did was they just give some sample input and output to the large language models. In the input, they told some random question, like question for which the answer is not possible. Right? For example, they created some random names and asked GPT or asked, let's say, Llama, that who is this person? Initially, before this training, Llama or Chat GPT, they are going to give you random answers. Even if the person does not exist, they will try to frame something. That is called as hallucination. They are going to give you wrong answer, but they'll give you with complete confidence. Right? So what Meta did was, it gave them some questions which did not have any answer. And in the output they mentioned, they asked the Llama model to give the answer as I do not know about this. I do not know about this. And then once the large language model started understanding that, yes, I can give the answer that I do not know about this, that is okay. Right? To show you some other sample data. Okay, so this is how the data looks like. For example, we want to understand about summarization. We want to make sure that our model is able to summarize. So we go give this kind of input. Summarize the following passage about neural network in one paragraph. A neural network is composed of layers of neurons that transforms inputs. Okay, so we'll give this prompt. And then this is the desired output. This will also be fed into the large language model. And then we will be able to retrain it again and again in this data to make sure that we are able to get the right answer. Right? We are able to go ahead and get the right answer. Okay, and then these are the methods in which we are going to test. It has to be clear, factual summary, and neutral tone. Right? So we give all of these feeds to large language model after it is created to the base model, and then we are able to get a more intelligent model. Right? Now, guys, all of this data, all of these files, all of these presentations, the notes and everything would be given to you if you remain till the end of the session today. And then we are going to go ahead and you go ahead and submit the feedback form. Okay. Yes. Cool. So I hope everyone was able to understand how large language models works. Everyone, please tell me on a scale of 1 to 5 if you're able to understand whatever I've told you so far. On a scale of 1 to 5, please. 1, you did not understand. 5, you understood it well. Cool. We have 821 people. Amazing. Great. Super, super, guys. Amazing, amazing. Thank you. Yes. People who are not able to understand, just look at the recording. I'm sure you'll be able to go ahead and understand this well. Yes. Cool. People who are not able to understand, please focus better. Please focus better in the session. Yes. Cool. Let me just go ahead. Yes. So now, based on whatever I have told you, now let us go back to economics. Okay, so we have talked about mathematics, we have talked about computer science, we have talked about psychology of a model. Now let's go back to economics and the business. Okay. So as a product manager, you need to understand at what levels is the value created in the large language models, by the large language models. Okay. So the first layer is the infrastructure layer. This is the layer on top of which large language models operate. Okay. What they do is, here we have companies such as NVIDIA and Google's Vertex AI, which provides the tensors or the GPUs where these models can run. So they provide computation, data, platform, GPUs and all. Right? So the core technology that you need, which is infrastructure, which is where do you deploy these models, is provided by these infrastructure layer companies. The second layer is the model layer. Companies who are creating and owning these models. Companies such as OpenAI, Anthropic, Meta, Grok, and DeepSeek. These are the companies which are owning these models, and they will give you large language models, small language models. They will also give you fine tuning. What is fine tuning? We are going to discuss in the coming sessions. Right. Now, this is the core. Now, on top of this, there is a bigger opportunity that you as a product manager can utilize all of these technologies, like these models, in order to build some amazing use cases. So Lovable, Gamma, ChatGPT, Gemini, they are all based on this model and the infra layer. So you as a product manager can play a very important role in the application. The application layer is how are you able to utilize the power of a large language model in order to solve the problems for your customers. Right? So internet is provided by someone else. The routers are provided by someone else. But Amazon has created an application on top of internet, which is able to give you the e-commerce at your doorstep. Tinder has created an application on the top of internet so that you are able to find your next date. Similarly, in AI, you should be able to create a lot of applications on the top of these large language models so that you are able to create a lot of value. Right? And the fourth layer is you can use these tools, you can use these large language model based tools such as ChatGPT, such as Gamma, such as Cursor, in order to make your clients and make yourself more productive. So service agency companies such as TCS, Realfast and all, they will use these tools and then they will help the company achieve their outcomes. Right? So this is the whole value chain. People create infra, then some people create model, some people create application based on model, and some people create services. Okay. But this is where you can drive a lot of value without investing a lot of money. And this is value at scale. Right? All of the companies here, all of these companies are same companies. They don't own models. What they do is they work on top of models created by other companies. Right? And they are able to generate a lot of value. Right? Now, based on this Gen AI value stack, we can divide multiple kind of AI PM jobs. Okay. So first of all, understand that every PM is an AI PM. If you are using any kind of AI technology in your life, GPT, Gemini, or anything, you are an AI PM. So I divide AI PM into two parts. The first part is the AI enabled PMs. These are people who are using products like ChatGPT, Lovable, Jira, or any other AI product in order to make themselves more productive, in order to solve problems for their customers, in order to save time, in order to provide more impact. So any PM who is a user of any of these AI tools, they are an AI enabled PM. So 100% of all of us are AI enabled PMs, right? The second is AI product PM. Now this is where the value is. This is what we are going to talk about, which we have talked in the last session, in the today's session as well initially, and then we are going to talk about today more and in the next session as well. Okay, so AI product PMs can be divided into two parts. One is the core AI PM. These core AI PMs need to understand how the technology behind AI works. So training, pre-training, post-training, how do you create a large language model? How do you store? How do you make it efficient? How do you consider memory of a large language model? All of these core things are the responsibility of a core AI PM. So people who are creating the infra or the model are the core AI PMs. These people need to be technical and they should have a solid understanding of machine learning in order to become a core AI PM. Whatever I have told you so far about how GPT works and all, this is a work of a core AI PM. The second kind of PMs where most of you should be going is applied AI PM. Now, applied AI PM are the people who are creating useful applications by using these core technologies. So people who are building Notion AI, Grammarly, Lovable, ChatGPT, people who are building these products are applied AI PMs. Applied AI means the people who are actually using AI tools like AI technologies, such as models and infra, in order to build something helpful for their customers. Okay, so these are the only the users, these are the core technology creators, and these are the product creators. Right. So can you guys tell me where do you fall right now? What is your best description right now? Where do you fall right now? Yes. Wonderful. So all of you fall under the AI enabled part right now, but eventually you should go ahead and, yeah, guys, everyone is trying to focus and learn. Please do not put any kind of links in the chat. I've already blocked a couple of people. Do not let me to do it more. Let us go ahead and focus on the session. Cool. Now, this is the differentiation. Everyone is here. If you are coming from already a very strong technical background, you should try to move here. But everyone, even if you are coming from a technical or non-technical background, you can always move here. This is where I want you to move. Okay. Now, let's go ahead. Okay. So tell me everyone if you are able to understand this meme. Look at this very carefully and tell me if you are able to understand this meme. Yes. Cool. So understand, there are so much valuation that has been created in all of these things. Okay. This is sitting on the top of LLMs. Okay. So I'm going to give you some examples of how various kind of technologies are working on top of these large language models. Okay. But we are right on time. We will take a quick break here. We will take a quick break of 5 minutes and then we will come back. Okay. So now let me go ahead and tell you so now you have understood that yes, a large language model. Okay. So there is something called as a large language model, which is provided by companies such as OpenAI, Anthropic, Meta, Google, and many more. Okay. These are the large language models that are provided by so many companies. Now, right. Now, this large language models can do 3 things for you. Okay. The first thing is they can understand content. They can understand what you are trying to say because they have seen so many patterns of data. They're able to understand what you are trying to say. Okay. So if you ask it to generate a summary, it will be able to understand the whole paragraph and then it will generate the summary. Okay. The second is it is able to transform content. Transform means if you ask it to create a summary of some content, it will transform that into summary. If you ask it to create a quiz on some content, it will be able to transform that into code. Okay. And the third part is it is able to generate content. So if you want it to generate images, code, anything, because it is data, it should be able to generate because it has seen enough code in its life. right? So it will be able to go ahead and generate. So as a large language model, the capabilities of so as a product manager, you should understand that there are three core capabilities of a large language model. The first is it can understand. Second is it can transform. And third is it can generate data, right? So you can use it for multiple ways. You can use it to generate summary. You can use it to generate answers for your questions. You can use it to generate code, and you can generate for almost everything that you want, right? And because they are being trained on tons of data, tons of terabytes of data, generally the accurations are very accurate. So now what happens? So far, whatever the software that we used to create, so far, whatever the software that we were used to create, these softwares were generally of four types. Okay, so any software that we have used so far, what they will do is they will generally create a data, they will read data, they will update the data, or they will delete the data. So all the software that we have seen, let's say Facebook, on Facebook, what happens? You go ahead and create a profile. And then on your profile, some database element is created, and then your people can see your profile. Some people can go ahead and upload some videos, and then you are able to see these videos and entertain yourself. So generally, most of the application before the AI world were actually create, read, update, and delete. This is called as CRUD application. But now AI has been able to give a brain to your softwares. So as a product manager, you need to understand what this large language model can do and how can I utilize it to create better products, right? So I am going to give you this understanding with the help of few examples. Okay, so there is a product called as Granula. Okay, and this product is similar to many other products. So it's a very simple product that if you go ahead and use Granula, it will go ahead and get added to your calendar. And whenever you are joining the meeting, it will take the transcription and recording of that meeting, and it is going to summarize the meeting for you so that you do not have to pick up a notebook every time. What happens is whenever we are joining the meetings, we have to write down that what are the things that are discussed so that we do not forget, and then we create a minutes meeting, like the minutes of the meeting, right? So there are multiple tools like Granula. There is Fireflies, Otter, Fathom. Most of them, which you can see also on the attendee list, right? Because many people have added their note takers. So now how these note takers are created, what is the value behind them? So I'm going to show you a simple tear down. Okay. So everyone, a quick yes or no in the chat if you understand what a AI note taker is. Amazing. Great. Yes. Yes. So now let us try to understand how this product works. And this is like a very important case. It will help you understand how AI products are built. Okay. So first of all, understand everyone. Whenever you create any product as a product manager, you have to look at 5 angles. Don't just go ahead and just think about technology. Technology is one important part, but it is not the most important part. But AI is just a piece of technology. So do not focus on just using AI. Focus on solving the problem of the user. So whenever you look at any product, please ask yourself 5 questions, right? The 5 questions are, what problem does it solve in people's life? Right? What problem does it solve in people's lives? Okay. So can you guys tell me? So think about it for a moment. And then tell me in the chat, what do you think, what are the problems that Granula solves in people's life? Think about this. As a product manager, this is the most important value that you need to add. That how am I being useful to the users? What problem does it solve? So tell me, what is the problem that these note takers solve? Yes, very good. So at a task level, it helps you record and summarize your meetings. but that is just an output. The outcome is that it is able to save you time and it will help you be more accurate, because when you are writing something, it might be possible that yes, you are missing something. And you also have to invest a lot of time and attention when you are writing things, right? So Granular saves you time. It makes you more efficient and accurate. Always remember, it is okay if you are not using AI in your product. AI is not a silver bullet that will improve your product. But if the product does not have a value, if you are not able to clearly define why this product should exist, then please do not create the product. Okay, this is the most effective value that you add as a product manager. Okay, now the second part, which is a business value. Why should the business pursue this opportunity? Okay, think about this for a moment, everyone, and then tell me in the chat, why should the business pursue this opportunity? How do you find this out? Let us keep it collaborative so that everyone is able to learn accordingly. Yes. So now what we will do is, we will try to understand that if we are creating a meeting assistant, how many people in the world are first looking for this kind of solution? So you will have a prediction that people who are a part of small businesses or large businesses, they are going to love this kind of solution because they are going to save time. And then you are going to understand how many people are there who are working in these small businesses, how many small businesses are there. And then you are going to size a market opportunity. Okay, that is one way that it is going to help the business because there is a large market opportunity. And in order to do this research, you can go ahead and use ChatGPT, Notebook LM, Gemini, or anything. Right? That is the business value. Now, the other kind of business value is, let's say, we are not talking about Granular, we are talking about Zoom. Right? So because Zoom already has a lot of users who are using its platform to conduct meetings, it is a strategic opportunity for Zoom. It is a strategic business opportunity for Zoom to create an inbuilt meeting assistant. Right? So it aligns with the strategy and it also aligns with the market opportunity. Right? So understand, everyone, as a product, before being an AI product manager, you are a product manager. And the purpose of a product manager is to bring the user value and to bring the business value. Right? Now, the third thing is, how do we make sure that the product is intuitive for the user to use? How do we make sure that the product is very intuitive? Right? So in all of these tools, you would have found that you do not have to do anything. You just install the tool, you add it to your calendar. Automatically, whenever a meeting occurs, the person, the meeting note taker would be automatically added. Granular goes to the next level, that right now this meeting is recorded with Granular, but you do not know. Why? Because it is installed on my computer, it is taking over the microphone and the video, and it is doing it by itself. So now you have to do optimizations on the design part so that you are able to reduce the friction for the user. If I have to add Granular every time, if I have to add this fireflies every time when I'm doing a meeting, that is going to be resistance for me. Right? So this is called as being a proactive software. So they are able to get into meetings automatically. So you don't have to do the work. Automatically it is happening. Right? So this is the intuitiveness. And then they have created an interface so that I'm able to see what are the meetings that I have conducted. I can go ahead and ask questions based on my meetings. Right? So this is the value part, business part, and the design part. The next part that we are going to understand today is how will this be engineered? Engineered part is feasibility part, but please remember this line: user value and business value as a product manager should be your first focus, and feasibility should be the next focus. Feasibility should not be the number one focus of a product manager right now. Please start with the user problem and the business problem. That is what you add the most to the company. That is where you are being most impactful, rather than only talking about engineering and feasibility, because there are people who are more eligible than you who can do that task. Okay, so how will this AI product be orchestrated? But before that, everyone, a quick yes or no in the chat if you are able to understand the three parts: user value, business value, and design value. Amazing. Wonderful. Yes. So there is one person who has said no four number of times. Great. So yes. So now we have understood the three parts. Now let me give you a bit about engineering. Okay. So this is how this product looks at the backend. Now look at this very carefully, super important. If you just understand this one product, I can assure you that you can reverse engineer almost any AI product. So please focus on this slide. Okay. So behind Granula, whenever you do any meeting on Zoom, on Meet, or anyone, Granula or Fireflies or Otter or any of the meeting recording tools, even the Zoom tool, they will be connecting to the meeting. Either they can join the meeting as a bot, or they will capture the content from your screen. Whatever you are speaking, they will take over your mic, or they are going to ask the API. API as in they will ask Zoom or Google Meet to share the recording or the transcript if you have given the permission. Okay, so they will get the audio of the meeting. Right? Once they get the audio of the meeting, they are going to convert that audio into text transcription. There are multiple APIs available for the same. So OpenAI has an API called as Whisper, where you give it audio, it will be able to give you the transcript of that audio. There is also Google text to speech, like speech to text, where you can just go ahead and give it audio. It will be able to convert into accurate transcript. Right? There are some smaller players as well, which are assembly.ai and other players who can also do this job. Okay, so now what we have is, we have a transcript. Now this transcript is available with us. What these people will do is, what Granula or Fireflies will do is, they will take this transcript and then they will add a system prompt. Okay, so this is a system prompt. So now everyone, please look at this very carefully. Look at this very, very carefully. So it is going to add this prompt. The prompt is, you are an expert chief of staff and note taker. Given the following raw meeting transcript, generate a structured and actionable summary that includes the following sections: meeting title, date and participants, key decision made, action items, open questions, summary, notable quotes, and then you have written some more instructions. Right? So this prompt might be created by a product manager at Granula, which will convert a raw transcript that is generated into very helpful meeting notes, right? And this prompt plus this transcript would then be sent to a large language model, right? This will be sent to a large language model, such as Gemini or ChatGPT, right? And then it will do its magic. It will create summary, actionables, and tasks. Okay, so this is how these meeting tools work. And then what happens? You can take it to the next step. You can make it more agentic. Agentic means they will take action. So what can happen is, they can also go ahead and push these tasks to your Slack, to your calendar, or to your Jira. So now you are just adding a meeting note taker, like a meeting assistant, to your calendar, and then it will get the recording, it will do the transcript, it will go ahead and create the summary with the help of system prompts and the transcript. Then it can go ahead and convert into multiple tasks, and then it can also, if you give it the permission, it can also go ahead and add it to your Slack, calendar, or Jira. right? So this simplistic architecture, which is dependent on multiple LLMs and things, is now a possibility because large language models are possible, right? Everyone, a quick yes or no if you are able to understand this, right? So I want you guys to think in this manner. Okay. I want you guys to think in this manner. Everyone, a quick yes or no in the chat, please. Yes. So now large language models have unlocked intelligence for you. Okay. Now you can use them like an expert in order to go ahead and do a lot of things, right? So now this is like a simple orchestration. Now you can think about how you can innovate on top of the same, right? So the history of Granula is that before Granula, there were players like Fireflies, Otter AI, and Fathom. What happened because of these was they will keep themselves added on. They will keep themselves added on. Yes, they will keep themselves added on multiple meetings, and people generally get irritated if so many bots are joining the meeting. Okay, and it was also not very privacy intensive for other people. Okay, that people do not want your bots to join their meetings. Okay, so Granula came up with a AI with a UI innovation. With Granula, you don't have to add anything. It will operate in your computer. It will listen to the audio, and then it is going to automatically transcribe the meeting for you and give you the context, right? So you can do these optimizations in order to make sure that you are able to go ahead and yes, you are able to go ahead and create a lot of things, right? Now, the magic that you can add as a product manager is understand AI is not difficult. You just have to understand the concept that I'm telling you. After that, the next real skill that you have to develop is customer empathy, understanding what customers want and giving them as soon as possible in the best design possible. That is the value that you add as a product manager. Okay. Now we have talked about Granula. Now let's go to the next level. Okay. So Granula is a very simple example. Okay. The next example that we need to understand is okay. So one part is left. That part is understand just building a product which is useful and business wants to build it and it is good design, it is good feasibility, doesn't make sure that product is actually very, very helpful, right? Doesn't make sure that the product is very, very helpful. So there is one more thing, okay? There is one more thing that is needed to make a product achieve its potential and generate revenue out of for the company, which is how do we grow this product in this market, which is creating a go-to-market strategy, building a product that is actually loved by the users, creating distribution for the product, making sure that people are actually using the product. That is called as the growth part. So how do you grow in this market? So all of these meeting assistants, they are viral by default. So let's say I and you did a meeting together, and because I believe in productivity, I do not believe in taking notes manually, I have added a note taker called as Fireflies. Now, when you see this, that in the meeting there is another thing which is Fireflies, you are going to get curious that what is this? I should also go ahead and check what is this. Okay. So by using virality, they are going ahead and creating a distribution, right? Similarly, whenever the meeting has ended, most of these people are going to send you emails. Let me show you one of the emails. Just give me a moment. Let me check if I have those kind of emails. What is the name? Fireflies. Cool. So let's say, cool. So this is the link. Okay. So generally when we do the meeting, this is the link that we received after that. Okay. So someone added me to their meeting and they also added Fireflies because they were using Fireflies. And after the meeting has ended, it always sends me this thing that this is what you have done. This is a summary. This is the action item. And it also tells me to go ahead, and if I click on view the meeting and all, it will ask me to sign up. Right. So these are some growth tactics that these people are implementing in order to make sure that it is able to grow. The product is actually able to succeed. So marketing and growth is also a good responsibility or a must-have responsibility for a product manager. Right. And understand, guys, product management is multidimensional. Not that you just create a great product and put all of your efforts into it and it is going to work. You need marketing, you need stakeholder management, you need a bit of understanding of technology, you need a bit of understanding of analytics so that you know if you are moving in the right direction. It's a multi-dimensional job. Right? So this is the story behind Granola. Now, let me go ahead and give you some more complicated examples. Okay. So tell me, everyone, if you ask ChatGPT, that what is the most important item in my Google Calendar tomorrow, would it be able to answer? If you ask ChatGPT that what is the most important item in my calendar tomorrow, would it be able to answer? Yes. If you're not connected to Google Calendar, it would not be able to answer. Right? And if I take example of, let's say, this particular product called as Calendar is connected to Google, but if I ask about Notion, then Gemini will also not be able to answer. Right? So now we have so much data in our calendar, in our to-do list, in our Jira dashboard, in our Stripe document like Stripe dashboard. But how do we make sure that all of this content is available to large language models so that they can go ahead and give us the answers? So rather than thinking that where is the PRD, what is the task that I need to do today from my Jira or Notion, I should just ask a query that what are the 3 things that I need to get done today? And then it should give me the answer. Okay. If I want to go to this level, what I can do is, a very simple approach that I can do is I can just go ahead and give all the data from my Notion or Stripe or Atlassian to the large language model. Okay. But when I give a lot of data to the large language model, what happens? The model runs out of context. Okay. Because these models cannot carry infinite context. Context means the kind of input that you can provide to these models. Right? So now we have to work hard to make sure that these models work. Okay. And also, although companies are trying to increase the context window as much as possible, there has been research that is done by great people at Chroma, which is a vector-based database company. They were able to find that as you increase the context, the performance of the model goes down. Even if these people claim that our model can work in so much context, when these people actually tested multiple models, they were able to find in almost all the models that as the context or the input size increases, if you increase the size of your prompts, then the quality of performance actually reduces after a certain level. Right? So now understand, as a product manager, so even if someone is not able to understand this or this, at least you'll be able to understand this. Okay. So when you give concise input context to the large language model, they appear to be very intelligent and very insightful and very careful. But when you go ahead and give them too large input, then they don't know what they are doing and they get confused. Okay. So now how to solve this? What we do is we have another methodology called as context engineering. Context engineering means how do you carefully curate what should go as an input to the large language model so that it is accurate, so that you have given the right kind of information, so that you are able to get the right kind of insight or output from the large language model. Right? So this is called as context engineering. So context engineering, I am going to quote the person who has coined this term, which is Andres Karpathy. So he says that context engineering is the delicate art and science of filling the context window with just the right information for the next step. Art and science means you have to apply your mind. You have to think creatively to give enough context to the large language model so that it is able to answer you in the most accurate format. Right? So this is context engineering. And in context engineering, we do multiple things. Okay. One of the point of context engineering is prompt engineering. How well you write the prompt is a part of context engineering. Okay. But apart from prompt, what happens is you need to give some data about your software. For example, if you want to build a software called as Notion AI. Okay. So let's say you want to build a software called as not Notion AI, but let's say you want to build a Bloomberg chatbot. What is a Bloomberg chatbot? Bloomberg is an organization which has access to a lot of financial data available in the world. Right? So now what you want to do is that whatever the data is available with Bloomberg, you should be able to send a question to a large language model in a natural language, and then it should be able to give you answer based on the content that is available with Bloomberg. Right? So here the problem is you cannot store all the content that Bloomberg has in the context window. You cannot have all this content as the input. Why? Because it is going to run out of context. So what you will do is you will carefully build something called as a RAG pipeline. Now, this is a very important concept. Even if you remotely want to become an AI product manager or an AI practitioner, you need to understand this. This is like a very basic thing that every person who calls themselves AI enabled has to understand. Okay, so RAG means retrieval, augment, and generate. Retrieval, augment, and generate. Okay, so what happens when someone comes to your house and they tell you that I need some sugar? Okay, when they tell you I need some sugar, you don't go to your study room and you do not look for sugar you do not start by looking for sugar in your cupboard or in your wardrobe or in, let's say, your library or maybe under your sofa. What you do is you straight away understand that sugar is an item that might be available in my kitchen in a particular shelf. It might be possible you don't know that which part of shelf that it is put on, but you know a particular shelf, or maybe you at least know that it is going to be found in the kitchen. Similarly, if your kid asks for a book or if they ask for money, you do not go ahead and go anywhere else in the house. You know where the money is put. You are going to just pick the room where the money is. Then you are going to pick a particular wallet. And then you are going to see in the wallet that, yes, in all of these 4 to 5 pockets, there could be a place where I have put the money. Right? So at a high level, you know that where this information is. The same analogy can be drawn to RAG. So in RAG, what we do is, the first part is we get all the data. We get all the data. For example, we have PDFs, or a better example is we have Bloomberg data. So Bloomberg data is they have a lot of files. So we are going to break down files into small chunks, maybe in the form of paragraphs. Okay. So we have one chunk, we have another chunk, we have another chunk. We are going to create all of these chunks, which are small enough and meaningful enough. Okay, we are going to break down this data. Now, in this data, what we'll do is, now we have the chunking of data. Now what we'll do is, we will convert these data chunks into something called as vector embeddings. Now listen to this very, very carefully. Super important. If you miss this, you will miss RAG. Okay. I'll repeat this again. You will take the data, whatever data is available, you will break it down into small chunks. And then when you have these small chunks, you will convert these chunks into vector embedding. So what is a vector embedding? So quick one-on-one on vector embedding, that like large language models, we have also created algorithms which are able to create any form of text into a numerical representation. Numerical representation as in, let's say, I have a word called as cat, right? So I have created a mathematical representation of cat. Okay, what is a mathematical representation? I have assigned some numbers. Okay, so let's say the number is 1, 2, 3. This is, let's say, x-axis, y-axis, z-axis. Okay, right now to show you, because we can only look at 3D, I am showing you 3-dimensional, but in reality, it can be n-dimensional, which is n is a very large number. Okay, so we take words, we take sentences, then we generate vectors from these sentences. Vector is this, like this point, right? And then what we do is, we keep on generating these vectors. Just a moment. Yes. So we keep on generating these vectors. And the beauty of these vectors is that somehow, when you search for cat and when you search for lion, okay, because these belong to a same family, they are going to be very closer to each other, right? When you plot something like a pat, it is going to be much closer. But when you go ahead and plot something like a table, then it is going to be far from cat. So mathematically, computer scientist has been able to create this vector thing. So what this vector thing does is, it will take a sentence or a piece of information, it will convert it into a numerical identity, which is a vector. And then these vectors are created in such a way that if you go ahead and compare these vectors with other words, based on the distance, you will understand how much this word is similar to that word or not in the meaning. Right? So this is vector embedding. Okay. So what is happening here? We have had the content and the text. We have converted them into long sentences of vector embedding, which is numerical numbers. Okay. Now what happens? And then we are going to store these vector embeddings into a vector database. Right? So now we have the data ready. We have data ready to be searched. So now what will happen? Whenever, just a moment, where is that? Yeah, so this is RAG. Look at this very carefully, everyone. So there are two parts of RAG. First, we are creating the knowledge base. What we have done is, we have taken all the content, whether it is text, PDF, transcript, code, or any Bloomberg data. We have converted that into small chunks, small information of data. And after that, we have created vector embeddings. And then once we have created vector embeddings, understand, there are standard programming code or functions to create these vector embeddings. Okay. Once the vectors embeddings are created, they are stored in vector storage. There are multiple databases that give you by default vector storing, which is Pinecone, Supabase, AWS S3, vector storage. It gives you all of that. Okay. Now what happens? A user gives a query. The query is, how has Tesla performed in the last quarter? Okay. Now what will happen? This query would be converted into an embedding. It will again be converted into vector. Now what will happen? We have two vectors. One is the vectors that are stored. Other is this vector. So if we want to see what are the vectors which are similar to this vector, which is where this information is stored, right? Where is that, let's say, where is that, I would say, wardrobe, or where is that place where in my kitchen, the sugar might be stored. Okay, so it is going to go ahead and understand this embedding, and then you are going to search for things which are similar to this embedding in this database. Okay. And you are going to pick maybe 1, 2, 3, 5, 10 things based on your algorithm, based on your needs, which are most similar to this particular vector. So you will have things which are most similar to this particular vector. Then what you will do is you will have some information. The information is you will go ahead and get this information, and then this will be your final prompt. So now you have taken the vector, you have found what are other similar vectors. Now you have created a list of the vectors which you have found. Now finally, you will get this. Now finally, you will have this. So you will give this prompt to the large language model. Just a moment. Yes, you will give this prompt to the large language model. Please observe this very carefully. Answer the question using the context below. This is the context. So chunk 1, chunk 2, whatever has been retrieved from there, whatever information. Okay, that information in the text form, it will be written there. Plus, this is the question from the user, which is the query, which is this. How has Tesla performed in the last quarter? Right? And then eventually you are going to go ahead and give this prompt to the large language model, Claude, Gemini, or anything, and then you are going to go ahead and get your answer. This is RAG in a nutshell. So we first create a vector knowledge base, then we get a query, we match that query for all the similar terms in the vector database, then we get all the information, we create a prompt, then we send it to the LLM, and then we get the answer. So now with RAG, what happens is you do not have to store all this information into your model or in the context. You can just cherry pick the information that is very relevant to that particular information, the prompt, and then you can get all the information at once. Okay, everyone, a quick yes or no if you are able to understand this. Amazing. Great. Super. Yes, people are not able to understand. If you just go ahead and submit the feedbacks form in the last, like in the next 10 minutes, I will give you the recording so that you can go ahead and do a revision. Cool. Yes. Cool. Guys, tokens and embeddings are different. Embedding is actually a meaningful representation of that particular sentence. Okay. But token is just, let's say, a vocabulary. Okay. It is just a numerical representation of particular word. Okay. Now, this is RAG. Now, in order to help you understand better, I have created a small app that I have vibe coded very recently. Let me show it to you. Yes. So this is a simple RAG process visualizer, which I created in just 10 minutes using Cursor and ChatGPT. Okay. And in the program that we offer at HelloPM, we are going to teach you how to do all of this. Okay. So let me show you what happens in RAG. So I've told you that in RAG, what happens? You have a piece of information. You first convert it into chunks, right? After that, you create embeddings. After that, you convert it into and save it to vector. And once a vector is created, you are going to write a query. And then from that query, you are going to match what are the matching chunks, how many chunks you want to match. And then you will go ahead and compose the query, as in the prompt is going to be composed, and then you will generate the answer. Okay, so let us see how it works. So I will take this thing. So I have written like this blog a very long time ago. So let me go ahead and do this. So I have taken this piece of information, let's say till this. I can take any kind of information. I will go to this. I will paste this content. Now the chunk size is 350, which is it is going to take 350 characters in a particular chunk. And the overlap of 80, which is there would be overlap of 80 characters between the first and the second and the third chunk. Okay, so I will just go ahead and create chunk document. Now look at this, chunks are created. This is the first chunk. This is the second chunk. This is the third chunk. This is the fourth chunk. So understand, this chunk was removed here. So it is in this detailed 4,000 words guide, setting the context how to build then rather than how. Okay. So now there is overlap in this chunk. So 50 characters are overlap so that all the chunks have a meaningful information. So now we have created the chunks. Okay. So what is chunking? Breaking down information into smaller parts so that they are meaningful and smaller enough. Okay. Understand? You cannot use the same chunking methodology for every application. If you are using RAG for code in order to retrieve code and in order to generate code, the chunking has to be done mostly at the functional level. If you are creating for a book, then maybe it can be done at a chapter level. If you are doing it for a meeting, it can be done at a maybe at a paragraph level. So chunking depends upon the product that you are creating. And tomorrow I'm going to tell you an evaluation that is how to decide your chunking strategy. Okay, so this is chunk. Now I will create embeddings. I'll create on embeddings. And then the embeddings are created. Okay, so if I look at this, these are the embeddings, guys. These are the embeddings. Okay, so for every chunk, I have created vector embeddings. Okay, and this graph that you are able to see, let me zoom it up a bit. So this graph that you are able to see is a representation of the vector. Now I will press the next button to save to vector DB, and then it will be saved locally. Okay, this is not connected to any server, so this is going to be saved locally. And after this, yes. And after this, I will write a query. The query is, what is AI product management? Okay. And I want to retrieve 3 chunks. Retrieve relevant chunks. And then these are the chunks. So these chunks, because there is product management and all, it is being accessed here. So these are the most relevant piece of information that I need to store here. So this is chunk number 8, chunk number 2, chunk number 3. If I click on this, I'll be able to see the complete chunk. Okay, this is the cosine, which is how distant these things are from each other and from my vector. Okay, and then eventually what I'll do is, I'll just create on compose query. Now the query is composed, and this is the query. Answer the following query based on only the provided data. User query, what is data product management? What is AI product management? And these are the chunks, 3 chunks. Okay, and then when I click on this, this will be sent to a large language model, and then I'll get the answer. I've not connected the LLM because I don't want to pay. And then we have this answer. Okay, but I can always go ahead and put my OpenAI key here, API key, in order to do this. Then the answer would be generated. Okay, everyone tell me on a scale of 1 to 5 if you're able to understand RAG now. Cool. Wonderful. People who are 4, I would recommend you to watch the recording once more, and then you'll be able to understand. Yes. Cool. So this was about RAG, super important concept. Everyone needs to understand. It will also improve your problem solving capabilities. Now the next part is prompt engineering. Okay. So guys, I'll only take 10 more minutes, and then I will share the feedback form. So if you have been here in this session for so long, please remain for another 10 minutes so that we can share the feedback form and you can learn the prompt engineering as well. Okay. Yes. Cool. So now we'll talk about prompt engineering. So understand, guys, you need to understand how to give instructions to your model. In order to give the right data, you have understood you have to use RAG. But in order to give instructions, you need to understand that you need to learn prompt engineering. Prompt engineering, no matter what the world says, it is a super important skill in today's world. Okay. Because you are using, let's say, AI and LLMs for so much of your time in a day, it is worth investing a couple of hours in order to learn prompt engineering. And also, if you are working as a product manager, as an AI product manager, prompt engineering is your way to interact with the LLMs. Okay, so it is worth investing few hours of your time in order to build great products. Okay, so this is also a guide on prompt engineering. So understand this products such as Firefly, Gong, Granola, which are almost $1 billion companies, or at least multi-million-dollar companies, they are based on these kind of prompts. So you should know how to learn these prompts. And I'm going to go ahead and give you some, I'll also share this guide with you. But right now, let me share with you few tips to improve the prompt. Okay, so right now, everyone, tell me out of 1 to 5, how would you rate yourself on your prompt engineering skills? How would you rate yourself on a scale of 1 to 5 on your prompt engineering skills? 3, don't give yourself 3. 3 is a very diplomatic answer. Yes. Many modest answers. Yes. Many reflective answers. Okay. So first is, please take a step back. So I'll not give you a very exhaustive guide that you are not able to even read. I'll give you a very simple guide. And this guide follows the Pareto principle. If you invest, if you learn these 20% of the skills as a prompt engineer, 80% of your efforts, like problems, are going to get solved. The first piece of advice is, please take a step back. Okay. Understand the value of prompt. What happens is, the unfortunate reality is that when you go to Chat GPT or Gemini, when you give it an very awful prompt, it will still be able to give you an answer. Most of the time, because it has given you an answer, okay answer, you go ahead and move forward from there. And then you start working on whatever you are working on. Okay. But understand, always remember, in many phases, in many places in your life, good can be the enemy of best. Okay. In many places in your life, good can be the enemy of best, which means you have to understand and recognize what is the value of this task. And is it worth investing a couple of more minutes or 5-7 more minutes in order to write this prompt well? Okay. So the first advice that I have for you is, please take a step back and understand if it is worth investing time in that particular prompt, if it is giving you that many results. Okay. The second part is right role. Whenever you go ahead and start using an LLM, please try to give it a role. Role means try to tell it that act as a person with 160 plus IQ, or act as a seasoned product manager, or act as someone who is a seasoned psychological therapist, right? So give these personas to the LLM so that it is able to perform well. If you want to experiment, you can share 2 prompts with ChatGPT or Gemini or anything. In one, give it a very solid persona. In one, don't give it a persona. You'll be able to observe the answers, right? So the first piece of advice is, please give it a right role. The second piece of advice is, please write the output expectation. Output expectation as in, you want JSON as an output, you want a table, you want to make sure that these mistakes are not repeated. Please write it explicitly. You have to be very, very specific. If you're not specific, it is going to do anything, and then you cannot go ahead and control it, right? The third part is multi-step. Multi-step means, rather than telling your large language model to give you answer at once, ask it to think in a step and give you a step-by-step answer. If you know the step, you can tell it the step. If you do not know the step, go ahead and ask it to tell you the step. For example, rather than asking ChatGPT that how would I improve this product LinkedIn, I would ask it that I want to improve LinkedIn. Please follow these steps in order to suggest me the improvements. First, understand who are the different users. Then understand their important problems. Then give me what are the top prioritized 3 problems. Then give me the solution of these problems. Then prioritize these problems and prioritize the solution, and then give me a particular solution. Now, when you are forcing ChatGPT to work in this manner, you are more probably like to get a better answer. Okay. So please do the thinking, let it do the thinking in multiple steps. Okay. After this, give examples. This is also called as few shot prompting. Few shot prompting means you are giving it few examples. You are giving it few examples that this is the format that you should follow, or these are the examples that make sure that you are able to go ahead and get the right content, right? And then we have constraints. So in example, what you can do is, whenever you are writing any piece of blog or any piece of article that you want to learn from, go ahead, copy the best author that you know, copy their blog, and then give it to ChatGPT. Okay. For example, what I do is, whenever I write some piece of content, because I have put a lot of efforts in writing this particular guide, I copy this guide and I go to ChatGPT and I ask that, go ahead. So let me show it to you. So this is ChatGPT. I am asking ChatGPT to write a detailed article on AI, on mistakes that people make while learning AI product management. Right? Now we will see the output. Yes. So you can see that it is writing, it is doing like a pretty interesting job, right? In the meanwhile, I'll also open a new chat. Right? So it has written this. You can see that it is well curated. This is point number 1, point number 2, point number 3, 4, this. Right? And so it's still writing, right? This is good one, right? Now what I'll do is, I will copy this article. I will copy this complete article. Maybe Control A, Control C. Right. So, okay. First, I'll go to this. Then I will write. So I've written the similar prompt. Now I'm writing. Make sure to follow the similar structure voice and helpfulness from this example. Okay. And I can go ahead and either I can go ahead and give it the link. It will be able to crawl the link, or I can just go ahead to be assured, I can go ahead and give it this content. Okay. So now I have given an example. Let us see how it works. Yes. Now you look at this. Okay. Rather than straight away jumping to what you should do, what you should not do, rather than straight away jumping to actionable, it is first setting the context. Why do you need this? This is the quick context. And then it is able to give you multiple mistakes and then how you can go ahead and avoid these mistakes. Right? This is a slightly better structure than you could have got in the first way. So this is called as few shot prompting, where you give examples to your large language model as in how they should operate. Right? And the other part is the similar example, which is constraints. Please give constraints. Constraint as in be helpful like this. Okay. Or constraint as in, if you want constraint in terms of, what do we call it? If you want large language model to not do something, then you should always include them as explicit constraints. Okay. For example, sometimes large language models assume a lot. Large language models actually assume a lot. Large language models assume a lot. So you can go ahead and tell them that please do not assume, only check the information that is available in this context that I have shared with you. Similarly, you will understand more about constraint when we talk about iteration. So understand, prompt engineering is called engineering. Prompt engineering is called engineering because it is iterations, which is you tweak your way around. You give it a prompt, you understand that I got the output, but the output does not follow these rules, or the output is not good in this particular way. So you are going to understand the output, and then you are going to give it the constraint that, boss, make sure that you are not taking unnecessary assumptions. Make sure that you are not using examples which are, let's say, very much vague or generic. Use specific examples. Okay. So when you go ahead and apply all of these steps, and when you keep on iterating on top of all of these 6 steps, you are going to learn how to design better prompts. Okay. Now, even after I give you all of this, I know that most of the people are lazy and they are not going to follow this. So now I'm going to give you a prompt guide for busy people. Okay. So 4 things that everyone should learn, and then we are going to wrap up the session. First is, please build a prompt directory. Whenever you come across good prompts, have a Notion document or a Google Doc where you are storing all of these things. Okay. So that you don't have to find your way through good prompts every time, right? Second is quick shortcuts. Okay. Keep a bookmark where you are able to access this library as soon as possible. So what I do is, whenever I want to write something, I do not want to find a writing pad. What I do is I just click on this new tab, and then I have all of my notes from Notion available here. Okay. Chrome new tab is the name of the extension, and then it is going to load here. Right now, I think Notion is down, so it is not loading, but now it has loaded. Okay. So all of my notes and everything is here. So what I've done is, I have set up a Chrome extension where whenever I click on this new tab button, it will automatically load my dashboard so that I don't have to run here and there. I can just go ahead and click on this, and then I can start writing my notes. And my prompt directory is also there, right? The other piece of advice is, use a prompt manager. Okay. So there are multiple prompt managers. You can use any one of them. And you can also use this prompt wildcard. Okay. If you are too lazy to write your own prompt, you can also get this wildcard, which is, analyze the following prompt idea. Analyze the following prompt idea, insert prompt here, rewrite the prompt for clarity and effectiveness, identify potential improvements or additions, refine the prompt based on identified improvements, present the final optimizing prompt. Okay. And also, there is a prompt creator from Anthropic. Okay. So there is a prompt creator called as Anthropic prompt creator. Okay. Where you can go ahead and create prompts. So it would be somewhere, or I have to log in order to see this, but you should be able to go ahead and generate this from Claude Console. Okay. Once you log in, it will give you a prompt creator so that you can go ahead and create your own prompts, which are much better than what you would have gone ahead and written by yourself. Okay. So this is about the guide to prompt engineering for busy people. Now, in tomorrow's session, what we'll do is, we will talk about Notebook LM, how does it works. We will take the similar kind of case studies, we'll detail it enough. Then we'll talk about fine tuning. Then we'll talk about how to choose between fine tuning, prompt engineering, and RAG. And then we'll talk about AI agents. Then I'll give you how products such as Lovable, Bolt, Emergent, and V0 works. And then we are going to go ahead and talk about MCPs. And then eventually I'll give you some examples of how to write AI evaluations. Okay. This is going to be tomorrow, but guys, understand, whatever I'm telling you in these 2 sessions, this is just 10% of what we offer in our bigger program at HelloPM. Okay. So at HelloPM, we have created the world's most detailed AI product management program. Okay. If you want to understand anything about the program, just go to this website called hellopm.co. Click on this video, and then I'll explain you what that content is. Okay. This is the most detailed, the most practical, and the most long-term support AI product management program that you can find. The content that I've told you today is just 10% of what we teach in the program, just in the first 2 classes. We will make sure that tomorrow you'll get a much more power pack session. So thank you, everyone. Bye and take care. If you have any queries, you can use the same form to publish these queries. Tomorrow, we are going to meet at the same time. Make sure that you also go ahead and bring your friends. Thank you, everyone. Bye and take care. You have been a great audience. I hope you got some value from this session and the 2 hours that you have invested. We'll meet everyone tomorrow. Thank you, everyone. Take care. Today is the day 2 of AI Product Management Masterclass. And we are going to give you almost everything that you need to get started in your journey as an AI product manager. This is the foundation. Now you can go ahead and explore the whole canvas in order to go into detail. But these are the major building blocks that you need to absolutely know if you really want to call yourself as an AI product management enthusiast, right? And because AI product management is so new, even if you are coming from a very senior background or you are just aspiring to be a product manager just straight out of college, this content is going to be equally useful for you. So yesterday, what we have done, we have talked about the agenda. I talked to you about what is the GenAI revolution. A lot of companies are building value on the top of this GenAI revolution. Then even in our normal lives, AI has found its way, right? Yes. Cool. Oh, I will stop the chat for some time so that you guys are not getting distracted. Yes. Cool. So AI has also found the way onto our daily lives. And almost every day we are using ChatGPT or Gemini or some of the other AI tools in order to make ourselves more productive and grow the impact of our work, right? And then I talked about the most fundamental unit why this AI boom has started, which is because of a particular technology called large language models. These large language models, these large language models are algorithms that are trained on massive amount of text, and they have learned the patterns of language really well, and they are now acting as the brain of the computers. And now what is happening, they are enabling us to understand, generate, and reason with natural language by predicting the next token most likely or the token in the context. And I have told you yesterday how all of these things actually work. I have given you the whole architecture of what an LLM is. The content is like, you will go ahead and take all the content as a training data from the internet. You will break it down into input and output. Then you are going to tokenize it. You are going to send the input from here. The neural network or the transformer is going to predict the next token. And then whatever is the right token from the training data, you are going to compare it. Then whatever is the difference, the feedback is going to be sent to the transformer again. And then it will keep on iterating. When this cycle happens billions and trillions of time, you will have a very mature model, right? But this model is only a base model. It is trained on some random data from the internet. So it has certain kind of biases. It hallucinates a lot. So what we do is we go ahead and do something called as post-training. Post-training means we are going to have some human labelers, or we are going to have some data annotators who are going to give some specific input and output, maybe in this particular format. Wait. Yes, maybe in this particular format where we are going to insert this kind of data, like well articulated inputs and well articulated outputs, so that the human can, the algorithm can go ahead and learn from the same. Okay, this is called as supervised learning. And one part of that learning is also called reinforcement learning through human feedback, which is humans are telling how, what is correct and what is incorrect, right? Humans are reinforcing the correct things by giving the rewards to the LLM. Now, after that, we talk about the Gen AI value stack. So there is multiple kind of values. For example, there are companies who are creating infrastructure such as these big NVIDIA and Google. Then there are companies who are creating the models, you know, about Anthropic and OpenAI. Then there are companies who are building on top of these large language models. This is where most of the value unlock is. And then we have companies and people who are actually using these AI tools in order to make their clients happy, solve their problems, and also solve their own problems, right? And then I discussed about type of AI PMs. Everyone who is using AI is AI enabled PM, AI tools such as ChatGPT and all. Anyone who is using AI tools is a AI enabled PM. And then we have other type of PM which are more serious PMs. These are PMs who are either working on core technologies such as databases, models, infrastructure. And then there are people who are working on the application layer. And these are the people who are actually using these LLMs and models and everything in order to build some truly AI products. Agents are one of the examples. ChatGPT is one of the examples. Grammarly is one of the examples. Lovable is one of the examples. So if you are building these products, not building with these products, you are building these products, then you are an applied AI PM. And the purpose of this session is to help you understand the core AI PM part and the applied AI PM part. Okay. For this part, we have already uploaded a lot of content on our YouTube channel that you can see. Right. Then I talked about how this application, these meeting assistants such as Granola works. Okay. And not only Granola, but if you take any of the meeting assistants such as Fireflies, Otter, Fathom, or anything, everyone works in the similar format. The format is whenever you want to create a product as a product manager, understand, please do not look only from the engineering or the AI angle. You are the product manager who is responsible to bring the user outcomes and the business outcomes. So please look at these 5 things. The first thing is, what is the value that is being generated for the users? Why would the users use it? Second is, what is the business value that is generated? Then there is, how do you make design so intuitive that people are able to use it easily? And then how it is feasible with the help of engineering. So all the system architecture is going to come here. And then growth and adoption. In Granular, we knew that this product helps us save time by recording our meetings and sending us the summary. How does it help the business? The business should invest in Granular, in creating Granular, because there is a large opportunity in meeting apps. So it is going to make money. Similarly, how do we make this intuitive to the users? By making the design very intuitive. How do we make it intuitive? We make the design intuitive by making sure that just after logging and connecting Granular or Fireflies, we don't have to do anything. Whenever a meeting is scheduled, it is automatically going to join that meeting. It is automatically going to generate the summary. It is automatically going to send the summary to everyone who was invited to that meeting, right? With just few clicks, you should be able to do so without your involvement. So that is the intuitiveness. Similarly, how will this be engineered? So I have told you about this. So let's say Zoom and Google Meet or any kind of platform is the place where you are conducting this meeting. Then Fireflies or Granular is going to either use the API for Zoom or Google, or they are going to do the audio capture through a bot. Okay, like you can see that there are a lot of bots in this meeting who are actually recording the meeting on the behalf of their administrators, right? After that, that audio is captured. And then there are tools called as audio to text transcription machine learning models, right? These models, such as Whisper by OpenAI, speech to text by Google, they are going to convert the audio into text transcription, right? And then you are going to attach a system prompt. So you as a product manager of Granular is going to add a system prompt, and then you are going to add a transcript. Let me show you that system prompt that I have shown you yesterday. So this is the prompt that you will paste. The prompt is very simple. You are an expert chief of staff and note taker given the following things. Please go ahead and summarize the summary of the, please go ahead and summarize the given transcript in this particular format. Right. So now what will happen? We have this system prompt, and then the system prompt is going to be combined with the transcript, and then it will be sent to large language models such as Gemini or OpenAI's APIs, right? Understand, this is happening at the backend. You do not know what is happening. You are just using Granular. At the backend, Granular is doing all of this. And then it will generate the summary, the actionables, and the task. And you can take a next step. You can make it into an agent by actually sending the tasks on a calendar, on your Jira, or on your Slack. So this is how any application which is a note-taking assistant can work, right? Even if you go ahead and understand a bit of vibe coding, you can also go ahead and create your own personal AI meeting assistant. This is the simplest architecture that teams use, right? And after that, we talk about a very important part that, yes, in this example, we were able to work with prompt engineering, but how do we go ahead and build applications which are able to work on the large set of data, such as data which is on your Jira dashboard, data which is on Notion AI, data which is on Stripe. So what we do is, we cannot, let's say I have a Notion database. I want to ask some questions on the top of the database. So I cannot just go ahead and put all of these content in the text, in the context. Why? Because the LLM is going to go out of context. And then there are researches that are conducted which have proven that with increasing context, the accuracy of the LLM decreases. With increasing context, the accuracy of the LLM decreases. And after this, we talked about the simple thing that if you are working with LLMs, try to make your inputs concise. Otherwise, they can go ahead and hallucinate too much, and they are going to run out of context and give you irrelevant answers. And then we presented you to context engineering. In context engineering, we first talk about RAG. So what is RAG? Super simple. What we do is, rather than putting all the documents, let's say I want to build a functionality where on my Notion document or on my Google Drive, I ask a question that what are the tasks that I need to do tomorrow? Okay. And somewhere in one of the PRDs, one of the documents, it is written that I have to do these tasks tomorrow. Okay. So in a non-ideal scenario, what will happen? I will try to get all the content of the Google Drive. I will put it in the LLM context of the LLM, and then I'll ask the question among all of this content, what is something that I need to do tomorrow? Okay, and then what will happen? Because it is a lot of content, the LLM is going to run out of context. So what we'll do is, rather than going ahead and taking all the data at once to the LLM, we are going to only find the content that is relevant, right? So what we do here is, we simply go ahead first, whatever data that we have, we break that data into chunks. And after chunking the data into small enough and meaningful chunks, we are going to convert it into vector embeddings. And after we have converted into vector embeddings, we are going to store in a vector storage. Once the vectors are stored, we will go ahead and get the user prompt, find all the relevant content from the vector storage, then convert it into text, and then ask this question to the LLM that based on these information, please try to answer this question. And then it will give you answer the question from the limited context that you have given, right? And I've also shown you a visual example with a RAG model that we have created, like a RAG vibe app that we have created, right? So this is about RAG. And then we talked about prompt engineering. Okay, I have shared with you some very simple but very effective tips, which is try to understand the value of prompt engineering. Make sure that you are giving it the right role so that it is more authoritative and you are getting the right answers. Then mention the output expectation very clearly. Do something called as chain prompting, where you are going to ask the LLM to think in steps so that it is able to go ahead and give you what is the reason behind this thinking. And then give examples. This is called as few shot prompting. When you don't give example, it is zero shot prompting. When you give example, it is few shot prompting, right? And then mention the constraints. Understand all of this is called as iterations, because once you give it a prompt, you will understand that maybe there is something missing. I should have mentioned this clearly. And then you are going to iterate on the prompt, and then you'll understand what are the constraints that you need to put. Okay. And then I have shared with you some advices and some wildcard prompts so that you can go ahead and get better at prompt engineering and writing better prompts, right? Understand prompts are your doorway to seize this AI opportunity, right? It is not just plain English. You need to go ahead and think deeper about the prompt so as to get the better answers, right? You have a very obedient and a very powerful individual at your disposal. If you ask it like awful questions, you are going to get awful answers. Now it's your responsibility to make sure that you're asking it better kind of questions, right? Yes. So this is what we have done so far. I think we have spent 15 minutes just in the revision. Now, everyone, please tell me, go ahead in the chat, if you have understood everything so far. How many of you are aware about this product called as Notebook LM? So in case someone has not used, I'll just give you a glimpse. Okay. So let's say I want to learn about AI product management. Okay. This is the topic for today. But sadly, I do not have time. I do not want to invest time. So what I'll do is I'll go to this platform, notebooklm.google.com. Okay. I will click on new notebook. Right. And now what I can do is I can give it a lot of documents, lot of resources, and then I can ask questions and summarize these documents from this interface. Right? On ChatGPT, when you give so many documents, it runs out of context. But it is this particular platform, Notebook LM, is working on RAG that I have just told you. So it will be able to answer. Let me show you how it works. Okay. So let's say I want to understand about AI ML product management. So I'm going to insert some resources. Okay. So the resources are, at HelloPM, we have gone ahead and done something called as the AI sprint, which has everything that you need to understand as an AI product manager. So I will click on this. Yeah, so I'll click on my channel, and then I'll click on playlist, and then I'll click on the AI sprint. Okay, so This is one video. So what I'll do is I'll copy the URL. I will go to Notebook LM. I am now collecting the resources. Okay, so my resource are these URLs. So I'll click on YouTube. I will paste the URL here, insert. So this would be inserted in some time. Second, so now what is happening? The Google Notebook LM is actually taking the transcript of the video. It is breaking the transcript into small parts. And then it is vectorizing all of these transcripts. Okay, all of the contents out there. Second, I will take maybe the second video. I will put it again in the YouTube part. Insert. Now I want a blog. So AIML, this. So I've written a blog as well. So I will go ahead and just add it here. And then I would put a link of website. I can put multiple URLs as well. Okay. So now I have all of this context ready. These are long 1.5 hour, 2 hours videos. And this is a very long, I would say 3,000-4,000 words of blogs. Okay. So now you understand that, yes, I have all the context available. I can go ahead and ask it any kind of question. And then these questions would be answered from the data that I have given. Right. So I will ask the question, what skill does a AI product manager needs? Now, this answer would be grounded in what is written in these sessions, right? So if you want to do any research of the world, you can just catch up some YouTube videos, some interesting podcasts from the founders and industry leaders, put up some blogs, put up some reports in PDFs from McKinsey and other companies, and then you should be able to do this. Okay, now it has given me the answer. But this is not the beauty. This is okay, this is cool, but it also has some wonderful features, which is it can help me create mind map, right? So if I click on this, it will create a beautiful mind map from all the concepts. Okay. Another important part is reports. So if I click on the reports, these are all the reports that it will create. It will create a complete blog post, which I can read. It will create a study guide so that it will be having a short answer, quizzes, some revision material, and everything. Then a briefing doc so that I can go ahead and just understand what is important in these particular 3-4 resources. And then there are multiple things. Okay, concept explainer, process overview, and everything. So it is now able to understand the content. And based on content, it is suggesting me that this kind of reports are possible from this. And I can also give my own report, right? So let's say I want to get a briefing. So now it will take some time in order to generate this particular report. Okay, and then I can also go ahead and create mind map, flashcards, quiz, and everything. And also eventually I can also create an audio overview. Okay, so this is what this product does. This is almost a #1 research tool based on AI, which almost every product manager and every individual should use. Okay, so this is Notebook LM for you. There are so many use cases. You just think about it and Notebook LM should be able to do these things, right? So my recommendation to everyone would be that after this session, go ahead and try to play around with Notebook LM. Super helpful tool, right? Yes, everyone, a quick yes or no if you're able to understand this tool. Amazing, thank you. Yes, so now let us try to understand, and also what I'm telling you is not just how Notebook LM works, but also any of the tools, any of the AI tools which are based on documents. So in Notebook LM, we are giving it a lot of documents and transcripts, and it is working on the same. On Notion AI, we are actually giving it all of our databases, the Notion document that we have created, it is working on the same. In Salesforce Einstein, we have all the documents that we have created in our Salesforce, all the sales record, all the CRM, all the emails, all the customer conversations, and then there is an LLM on top of it. So the mental model is that if you have a lot of data, and if you want to put a LLM on top of it in order to make it more queryable with the help of a natural language, then this is what you should do. This is the same architecture for all of these products. Okay. Yeah. So what we do is we follow the same format. Question number 1 is, what problem does it solve in people's lives? This is something that you need to answer as a product manager before even building the product. So why is Notebook LM helpful? Because it helps people conduct research by helping them read so many documents and summarize these documents at once. It helps people read and learn about exhaustive full topics within a lot less period of time. It also helps people create some effective notes for their learning, for their research, for building any product, or for doing anything. Okay, so there is definitely a value in the product, right? So it will help people become more productive and take better decisions in shorter period of time, right? What is the business value? Now Google has understood that people are using ChatGPT a lot, and Google has understood that now if people keep on using ChatGPT and Perplexity, the research that people used to do on Google is now going to get reduced. So they have to create a product that will make sure that they are getting their lost foothold. And now Notebook LM has become popular, that people have started using it. So it is a strategic bet for Google to create this kind of product, right? Third is, how do we make it intuitive to use? So Google has made it very simple. So you can see the UI. It is very simple. It tells you, so Google might have thought that why not we go ahead and allow people to just enter content? Okay, but content could also be in the form of YouTube. So they explicitly mentioned that yes, people want to learn from YouTube, so you can enter YouTube. People want to upload their PDFs, so they are allowing you to upload the PDFs. So they understood that from what kind of resources people would want to ideally get the information, and they have enlisted all these resources. Similarly, they were able to understand that most of the people are very lazy in terms of prompt engineering. So they are giving you some automatic templates of reports. So rather than you thinking that what is the question that I asked from this document, they will give you automated question in the form of report that I have just shown you. Right? So this is how you make the product more intuitive. Right? And if you guys want to learn how to make the product more intuitive, a simple exercise is go ahead, look at 10 top AI products, and then reverse engineer what are the things that they are doing in order to make it more intuitive. You can follow the similar kind of principles. You will be ahead of 80% people who do not know anything about UI, right? And then we have, how will this be engineered, right? How will this be engineered? This is the structure. Please look at this very, very carefully. Okay. Yes, we have 510 people in the chat. Everyone, please write focus if you are ready to go through this. Please write focus if you are ready to go through this. Amazing. Great. Cool. So focus here, everyone. So here what is happening is, first is the resources. Resources are in the format of articles, videos, PDFs, and text, which is videos, it will not be able to understand. So what it does is, it takes a YouTube videos, and YouTube videos comes with a transcript. So it is understanding the transcript and not the video. Okay. Second is PDFs. To convert PDF into text, we can either, if the PDF is created digitally, we can go ahead and convert it into text, like through some PDF extractors. However, if it is an image that we have taken photos of and then we have converted the PDF, then we have something called as OCR, or optical image recognition, character recognition, right? So these things would be created. So understand, it is not just that building an AI product is only about implementing the LLM. You have to do this dirty work as well, which is making sure that all the content is in the right format, which is text. Right? After this, and even if let's say we have audio, right now I don't think it allows audio, but if it allows audio, what it will do is, it will get the audio from you. It will give it to the backend, like from the backend, it will give it to Google speech to text API or Whisper API. And then it is going to get the transcript, and then the transcript is going to be added here. Okay. So as soon you add the sources are extracted, they are chunked, and then they are chunked at two levels, document level and the paragraph level. Right. So it tells you that from which document and which part of document is this content coming from. So whenever you are storing these chunks, there would be a link to that document, whole document, like the source, and there will also be a link to that particular part of the document, which is the chunk, right? I have shown you this example yesterday with that thing, right? After this, we have embedding. So now this will be stored in Google's own database for embedding. And understand, whenever you change the content, whenever you update the content, this is going to get refreshed. Right? Till here, we have not used the GenAI so far. We are only using engineering, computer science engineering so far, and some machine learning algorithms. Right? Now what happens? Your platform, Notebook LM, is going to understand what this content is all about. So it will try to go ahead and create high-level summaries of all the documents that you have created, like high-level summary for every document automatically. And then it will try to understand what are the different kind of reports that I can generate. And for generating these reports, it would have some kind of templates already. So let me show you. So this is what Google might have created at the backend. Okay. So let's say if we think that there could be a summary that we can create. So it will go ahead and give this kind of prompt, which is summarize the key ideas in the plain English, focus on main findings and implications. If they need to create a study guide, so here what is happening is we have these report prompts, right? It will show you that these are the things that you can do with this report. And then the user input, whatever the user has inputted, the prompt and the retrieved context. Retrieved context means whatever is matching with that prompt. Whatever the words that you have mentioned in that prompt, whatever is matching in the vector database, that is going to be fetched, and then that will be sent to the LLM. If it is Google, the LLM is most probably going to be Gemini. So this is the prompt library. Okay. So if the summary type, the report type is summary, then this is the prompt. If it is a study guide, then generate a structured outline with key components, definitions, and questions for self-testing. Right? Mind map, organize the main ideas hierarchically with branches for sub-concepts and examples. Right? And then reports would be generated, and then reports could be summary, mind map, guides, FAQs, and then what will happen? You as a user will give the feedback that it is good or it is bad, and then it is going to go ahead and auto-correct these prompts. And you can also go ahead and put your own prompts. So what is happening? This is augmenting. This part is retrieval, and this part is generation. Right? So we are first creating the documents, then we are generating, then we are going ahead and giving it to the LLM, and then we are generating and giving the output to the user. Right? So this is how Notebook LM works in a nutshell. It is a pure play RAG application. Right? Everyone, a quick yes or no if you are able to understand this. Now, one question to everyone. Okay. Let's say if I ask the question to Notebook LM that summarize all the contents, summarize everything that you are like from all the resources, summarize. Now, what do you think will happen? Think about it for a moment and tell me in the chat what will happen then. Let's say if I give it a query, give me a summary of this content, what will happen? Now, so summarization, yes, cool. So understand, summarization is a non-typical task. Why? Because summarization is the most, I would say, popular task, but it is a non-trivial task. Because in the prompt, what would be mentioned? Summarize this document. When this is mentioned in the prompt, when it will search in the RAG model, when it will search in the embedding, what will it search for? Summarize, article. And now, how will it find that where is summarize and also? Because it is doing a vector-like search. So it might find some chunks where summarize, brief, executive summary, these kind of things are written, but summary would not be accurate. Right. So what is the solution? The solution is we do not implement this normal RAG pipeline in these kind of applications. What we do is we have something called as hierarchical RAG. I'm not sure what the spelling is. So hierarchical RAG, what it is that I have source 1, I have source 2, I have source 3. Okay. So now, first of all, understand the problem clearly. Okay. I have created chunks. Let's say there are 10 chunks that are from this document. There are 10 chunks from this document and 4 chunks from this document. If I ask LLM the question that please summarize this, then what will happen? It will make the vector of summarize, right? And summarize vector might be equal to brief, okay, or maybe some other things like synonyms of summarize, right? And it will go ahead and try to find summarize, brief, and some things in these chunks. And whatever are the chunks that are relevant, it will go ahead and give these chunks. Let's say one chunk from here, one chunk from here, and one chunk from here. So we have got 3 chunks, right? But understand, these chunks are incomplete. They have mentioned summary or brief or in short something, but they do not contain the true summary. They just contain these words, right? So what we will do here is we maintain a summary at a high level. So for all of these documents, as soon as you upload this document in NotebookLM, it is first going to generate the summary of the whole document. So it will send it to the LLM. It will generate the complete summary so that it understands what the report is. Then for the other, it is going to generate the summary. For other, it is going to generate the summary without you saying anything. And then whenever you send a query of summary, it will understand what the equation is. And then it is going to answer by concatenating or copying or taking all of these summaries into the context. That way, context is also not increased, but there would be some more LLM calls. Right? So how we have solved this problem? We have taken all the sources automatically without even the user saying so. We have taken the summaries of every individual source. Right? And once we got the summary from the LLM, now whenever a user is asking question about summary, we are going to combine all of these summaries in order to get a better answer. Right? Yes. Everyone, a quick yes or no if you're able to understand this. And like this, guys, although RAG is simple, okay, RAG is not a rocket science, but you have to understand the nuances. Every product is unique. So you have to understand these kind of nuances before going ahead and calling yourself an AI product manager. Okay, so this is about how NotebookLM works, and all the RAG applications works in the similar format. You have the knowledge base, you convert the knowledge base into the vector database. After that, you go ahead and get the user query, you match the pattern, you get the top similar chunks, and then you put the LLM on top of it along with the system prompt. Right? Yes. Now, in the context engineering, we have so far talked about RAG. We have talked about prompt engineering. And the third part of context engineering is actually fine-tuning. So sometimes what happens is you have to retrain the model. You have to change the parameters in the model for your use case. For example, Google has this amazing model called as Alpha. Okay. Google Alpha. And Google Alpha Fold or something is the name. Alpha Fold, I think. Okay. So what it does is it is able to identify the patterns in protein, and then it is able to suggest that what is going to be, let's say, the consequences, which is the diseases which are identified from protein patterns and so many things. Okay. But understand, when ChatGPT or Gemini was trained, it does not have any information about proteins and all. It has the information about how normal natural processing works, but it does not have any understanding about how to understand the protein models. Okay. So now what happens is we are going to take some new data which only contains information about these protein folds. And then we are going to go ahead and retrain our large language model again, so that now we have context and information about this. So if there is some information that is completely lacking, that cannot be compensated with RAG, then we use fine-tuning. Plus, sometimes when you have to change the personality of the model. For example, this is a real use case that one of the bigger banks, they used ChatGPT in order to answer the customer queries, right? And then they were able to find that ChatGPT is able to answer well, but it does not have that personality of how their people were actually going ahead and answering. So what they did was they actually taken all of their past records of the chat which humans have done. They have fine-tuned GPT and other models on the top of the same, and then they were able to get a new model which is now able to act nicely, right? Similarly, Bloomberg has created a product called as Bloomberg GPT, where they have trained complete Bloomberg on top of a GPT on top of Bloomberg data, so that if it has that kind of context, right? That kind of information and knowledge. So fine tuning is adopting a pre-trained large language model, which is a chat GPT or any base model, with a domain specific data to make it more useful for a particular task, right? So what we do is we take a base model, Llama, GPT, Sonnet, then we do the fine tuning with curated data and examples, and then we have a fine tuned LLM. Okay, it is one line of code which you have to use in the OpenAI terminal. OpenAI API fine tune, create t data.json, whatever the data that you have, then this is the model that you want to train. One line of code can go ahead and do the fine tuning, but understand fine tuning is the costliest of all the three methods that we have talked about. Fine tuning takes a lot of money, a lot of resources. So unless you are not sure, you should not start with fine tuning. First, do prompt engineering, then try to understand if the problem can be solved with RAG, if it is lack of information problem. If it is not solved, then you should go ahead and go to fine tuning, right? And generally fine tuning is of two types. One is full fine tuning. Second is parameter efficient fine tuning, or PEFT. Okay, so in full fine tuning, what happens is whatever are the billion parameters that we have in the large language models, we are going to try to update them all. So it is very intensive, right? So this is going to give you great results, but it is also going to be very, very intensive on the CPU and GPU, and it is going to cost you a lot of money, right? Similarly, we have parameter efficient fine tuning, okay, where what we do is rather than, so I have talked about parameters in the last class. In parameter efficient fine tuning, rather than going ahead and optimizing and changing every parameter, we only change few parameters to make sure that model is able to get that behavior without spending a lot of money on training, right? So it updates the subset of parameters. It has lost, cost, and store, right? And the training can be done faster. The examples are adopters and LORA, LoRa, right? So this is called as fine tuning in LLMs. Now, a major question is, when should I choose what to do? Whether I should do prompt engineering or RAG or fine tuning, how should I choose? So this is a simple decision tree for you. Okay, if you want to decide the right contextualization method, this thing is called contextualization or context engineering. If the base LLM is good enough with careful prompting, then go with prompting. Experiment, try with prompt first. Before going to advanced method, try with prompt first. If it is giving you the answer, go ahead and do this. There are multiple products that are based on the same. For example, Granola and ChatPRD, they are only working on prompt engineering, right? Second is, if it is not working, prompt is not enough, then if the problem is only about missing or dynamic knowledge, then go ahead, use RAG. Strike, Notion AI, Notebook LM, they are using RAG, right? And the third is, if the issue is about style, tone, or a domain specific behavior that you will understand by asking questions to the LLM, then you should go with this. And examples are Duolingo Max and Bloomberg GPT that I've already given you examples of, right? So guys, this was context engineering. Everyone tell me yes or no in the chat if you are able to understand everything so far. We talked about prompt engineering, we talked about RAG, we also talked about fine tuning, right? And the question is that what you should use. What you should use is usually decided by your context and your problem. Okay, don't think that if some company was able to use something and get the results, you will also get it. Please try to understand the user problems, the context, the limitations, the trade-offs, and then choose whether you should go with prompt engineering, RAG, or fine tuning. You should always start with prompt engineering. If there is an issue with data, go with RAG. And then if the issue is with personality or the base data, then go with fine tuning. Right? There is also an interesting thing that is coming across these days. I'll just give you a hint. We talk about this in detail in our bigger program, which is an amazing thing, which is called as transfer learning. Okay, this is an upcoming I would say very promising field, and many companies are going to adopt this. Just a moment. Yes. So there is something called as transfer learning. So what we do is, the issue with large language models is that more intelligent the model, okay, more it is going to cost and more it is going to have latency, which is it is going to take more time to respond. So if you go to the OpenAI API, okay, OpenAI API cost. Okay. So if I go to pricing, understand that this GPT-5 is their best model. And the cost of GPT-5 is for output $10 per 1 million tokens. Right. And then they have a small model, which is GPT Nano, which is $0.4 for 1 million tokens. Almost 25x difference. Right. So models which are small models, have less number of parameters, are more efficient and cost effective, but they do not have the right kind of, they are not trained on more data and they do not have more parameters. That means their output could be a bit here and there. Okay, so we have something called as transfer learning. What we do is, we pick a small language model such as Gemma, or a combination of, or something between the small and the large language model such as Nano, which is GPT Nano, 5 Nano or 4 Nano, whatever you want to choose. Okay, these things have less cost. What you will do is, you will go ahead, generate some synthetic data from the top models, which is GPT-5 or Gemini 2.5 Flash. Okay, you are going to use Gemini in order to generate some synthetic data, and then you are going to generate that data, and then you are going to fine-tune these models on that data, so that these models, although they will not get as intelligent as GPT-5 or Gemini 2.5, but still, if you give them specific use cases, for example, if you are using for customer support, if you are using for coding, if you are using for coding in a particular language, if you are using for a particular use case, then you can generate enough data, and then you can retrain these models with fine tuning. And then there is going to be one-time cost of fine tuning, but then eventually your overall cost of API and inference will reduce. This is called as transfer learning. So you have a small language model, which is efficient, which has less cost, but it does not know about certain knowledge. So you will generate that knowledge artificially from bigger models, put that knowledge into fine-tuning data for these small language models, then the small language models will become more powerful for your context. Right? So imagine these large language models as swords. But sometimes, for some purposes, you don't need a sword, you just need a needle. And then transfer learning gives the power of sword to this particular needle. Right? A quick yes or no, everyone, if you're able to understand the power of transfer learning. You can explore more about this. We talk about this in more detail in our bigger program. Super helpful skill for any product manager, because implementing LLM and understanding is easy, but getting the most out of from this is super important. Yes, cool. Now, with that being said, let us go ahead and talk about the interesting piece in the room. Okay, which is AI agents. So far, the AI agent was like your most interesting, your most intelligent manager. They are telling you that this is what you should do, this is what you should do, this is what you should do, but they are not taking action. And nothing is more frustrating than a hands-off manager, because they don't know how to do the work, but they always try to give you knowledge and gyan. Okay, and LLMs are the same. You give them the input, they give you the output, and they appear the most intelligent part, but they cannot act. Act means you do not want the LLM just to write an email. You want them to send the email and take the follow-ups. You want them to do your work rather than just being uh, uh, your brainstorming buddy. So in order to give agency to the agent into the AI, we have something called as AI agents. So AI agent is nothing but a very simple concept, okay, which is we give access to some actions to our agents. We get our AI to act. So what we do is, a simple example of agent is, let's say I post very frequently on LinkedIn. Okay. And if someone wants to go ahead and be updated with what is happening in the product management world, what they can just do is go to my profile, look at what I have recently posted, and then you should be able to understand what is happening in the AI product management world. Okay. But this thing you have to do manually. What if there would be a large language model? What if there would be a software or an agent that can go to my profile every day in the morning, look at the 5 recent posts that I have done, let's say not every day, but let's say in a week. In that week, whatever I have posted, they should collect all that post. And then they should give all of this post to a large language model, which can summarize all the important content. And then it can send me an email. This is an example of a large language model. This is an example of an AI agent. Okay, which is I am choosing a time where I am going to crawl a profile, LinkedIn profile. I'm going to get all of their posts. Then I'm going to summarize this content, and then I'm going to get them to send an email. The summarize part is the intelligent part that is done by AI. That is why it is called as an AI agent. Right. Now I can go ahead and tweak this AI agent more. What I can do is I can tell the AI agent that rather than getting the post from someone, you only go ahead and send me the message. Rather than crawling all the post, you should only go ahead and crawl the post where something is written about AI product management. So now the AI agent will go ahead and take some calls based on, or take some decisions based on the content that it finds. So when the AI agent is taking some decisions based on its own context, then it is called an autonomous AI agent. When it is just going ahead and following the instruction, it is a workflow agent. Right? A quick yes or no, everyone, if you're able to understand the example of AI agent. Cool. And we'll actually create that agent today. Okay. So intelligence, autonomy, and action. Right. And there are multiple platforms, guys. Understand, building AI agents these days is not rocket science. It is commoditized information. How to build great agents is something that you need to learn. Okay. So if you go to platforms such as agents.ai, Zapier, Anit10, and OpenAI has very recently created their agent kit, you can go ahead and create multiple agents. Okay. However, there has been a report recently. And this report got way too popular. And it has mentioned that 95% of most of the AI initiative, most of them were AI agents, have failed. And the reason being, there was a learning gap. Learning gap means these projects did not fail because these people were failing to engineer agents. They were able to create agents. But the problem was these agents were actually not solving any good enough problem. And it was not learning from the feedback. Right? So anytime you want to go ahead and build any kind of product, please remember this. If you are creating AI agent, if you are creating a normal traditional product, or even if you are creating an offline product, please make sure that you start from these two things. If you read this report, I'll attach this report in the resources section when we are sending this to you. You will understand why not having the right product sense was a major problem, why these things fail, rather than just not knowing about the AI. So understanding AI is easy, but using AI at a scale is a different beast altogether. Right? Yes. So this is simple about AI agents. I'm going to help you understand how AI agents are built. So a quick yes or no, everyone, if you have ever built an agent. A quick yes or no if you have ever built an agent. Cool. A lot of no's. Cool. So I'll okay. So understand, N10 is also a fantastic flow, but I'll show you something even simpler. Okay. So you can go to this app. called relay.app. This is free with enough credit, so I'm using this. Okay, and it is very simple. Okay, so I'll click on login. I might be all logged in already. Okay, so I'm already logged in. Okay, so what I'll do is I'll create a simple flow. Okay, so I'll click on new workflow. Now, every agent starts from a trigger. Understand, guys? This agent, I'm telling you these agents that you can build. The production grade agents are different. The products that I'm going to give you examples in just a moment, they are also agent. But right now we are using like a agent that you can also build on your own. Okay, this is for your own productivity. Okay, so the agent is, yes, so the agent is will do the simple thing. At 8 a.m. in the morning, it is going to crawl my profile or any other profile that you want to. It will take all the posts and then it will summarize these posts and then it will send me an email. That's it. Okay. Summarization will happen with an AI. So add a trigger. Trigger means when should this event happen? When should this event happen? Okay. So I will just go ahead and click on schedule trigger. It should happen tomorrow or today's 26 today at 8 a.m. So this time has already passed, so I can make it tomorrow. Okay, it can run at this time and it should run daily. I can also make it any other time. Okay, this is how the event is triggered. Okay, and then I'll click on done. To make it simple, I have chosen this frequency, but you can also execute your agent on any other event. For example, when you send a message to Slack, when you send and get an email from someone, when you go ahead and maybe send a message on Telegram, when you go ahead and click a button, when you go ahead and get a new lead from your CRM, you can go ahead and add any kind of triggers. Okay, this is just to make it simple, keep it simple, right? Then we'll add a step. The other step is I want to add LinkedIn. So on LinkedIn, I will just click on add the step. I will search for LinkedIn and then get LinkedIn comments person post. I want some person's post. I'll click on this and then I'll select a URL. So what is my LinkedIn URL? I'll go to this LinkedIn /in /Ankit Shukla. So this is my LinkedIn profile. I'll just click on this. I will enter manually. I will enter this. And then I want to get the top 10 posts. And then if posts are not returned, then continue without a result and then done. Second step is done. The third step is I have to summarize. So I will summarize. And then what will I summarize? I will summarize posts. Next. It will automatically tell me what you want to summarize based on what I have sent from the last step. Okay. And then this is the prompt. Okay. I can do it better. I can go to ChatGPT and I can ask ChatGPT that write me an effective prompt to summarize my LinkedIn posts. Right? So I will go ahead and copy this. Right? I'll go ahead and copy this. Okay, but to keep it simple, I'm not using this, but you can just go ahead and copy this and paste it there. Okay. I'll go ahead with the simple one, which is summarize the attached post, use fewer than 100 words. Okay. Then access to this. Okay. Plain text. Okay. Done. Right. And then we have plus button, which is I want to send myself an email whenever this happens. Email, send email to yourself. What is the subject? Summary from Ankit's post. Add body. If I write egg, if I write egg the rate, I should be able to get the summary. AI output. Summary is above. Okay. And then I'll go ahead and click on done. right? And now, okay, so everyone so far, write yes or no in the chat if you are able to understand the flow so far. It is super simple, right? Correct. And now what we'll do is, we will just go ahead and try to test this. Start now. I can test this, right? I don't have to wait for morning tomorrow because you guys would not be there. So I will test this. Summarize with AI, and then an email to yourself. I'll click on this. This is the email. The post primarily promotes a free multi-session AI PM masterclass, which drew over 800 live attendees. The masterclass focuses on mastering LLMs, this, and this. I hope you guys remember this. Right? Now, guys, tell me confident in the chat if you are confident in creating your own agents now. Tell me confident in the chat. Yes. So understand, this tooling was never difficult. This tooling was never difficult. What one thing that AI has done is, it has gone ahead and made things simpler for everyone. It has gone ahead and made things super simpler for everyone. Okay. As a person, you need to understand that now you have so much power, and you have the power to exercise this power. You have the ability to exercise this power. Okay. Now you should focus on the right use cases. Okay. So what I'll also do is, I will share with you a list. So Google has created an amazing guide. Google has created an amazing guide which talks about what are the different kind of use cases in different kind of industries for AI agents. I will share this guide also with you in the slides so that you are able to understand. And then create agents there. First, whenever you create any product, understand the users and the business. An AI product manager is a product manager before they are an AI product manager. Okay. Tools are easy. I have already taught you the tools. They are not so difficult. Important thing is understanding to solve the right problems. Okay. And then when you create an AI agent, these are the things that you need. So this is a general stack that you guys can go ahead and take a screenshot of. In an agent, you need reasoning so that you can summarize, you can take decisions, you can call certain kind of tools, right? And generally LLMs are used. LLMs, large language models, are GPT, Claude, Llama, and others. And small language models are Phi 3 and Gemma. Right? Similarly, you need memory. For example, if you in chat GPT, it remembers everything that you have told. But when APIs are called in agents, they might forget about your older conversation. So you need to save your memory. Okay. So understand here what has happened in this model. What is memory? Let me tell you. So in this model, in this flow, it found 10 posts, then it gathered the data, it sent the data to the other step where the AI summarized it, and then it was able to get that memory, that data, that summarization to the next step. This is called as memory. Making sure that LLM and the whole model, the whole agent is able to remember what you just said, right? This is called as memory. And for memory, we have multiple tools. For memory, we have vector databases such as Pinecone, Chroma, RAG, and feedback loops, right? And then there are tools. Tools can be accessed with the help of databases, visual agents, and APIs. APIs are available. There is something also called as visual agents. Visual agent says it will, if it does not have an API, it will act like a computer. It will browse, it will click buttons in order to get the data for you. Okay. And then, so OpenAI operator is example of a visual agent, right? Then we have orchestrators, platform on which you can create these kind of tools, these kind of agents. So LangGraph, Crew AI, NA10 is these platforms. I have given you a new example today, which is a relay.app. And then we have guardrails. So now understand, AI agents are like fire. You can use them to cook your own food. You can use them to show away danger animals, and you can also use it to burn your own hands and burn your own home. So guardrails are super important. Guardrails make sure that your content is relevant, your agents are safe, you are not abusing the tools, and then you are also validating the output before presenting it to users. Right? In our major big program, we tell you about in detail of all of these things so that you are able to build some secure agents, production grade agents. Right? Yes. And these are some examples of agents which are useful. Customer support agents, which will read tickets, drafts, replies, and then update the CRM. Meeting productivity, such as Fireflies and Granola that we have discussed yesterday. And BizOps, business ops, which is Zapier AI or end agents that monitor incoming data and execute automations. Right. So this is in a nutshell what agents are. Okay. Now in the next part of the class, we are going to talk about how platforms such as vibe coding platforms such as Lovable, Boat, Emergent on V0 works. Okay. But right now, let's take a quick break. Okay. So before that, everyone tell me on a scale of 1 to 5, how good are you able to understand everything so far? Great. Cool. Amazing. Cool. So now, everyone, a quick break of 4 minutes, and then we are going to come back. Quick break of 4 minutes and then come back. I think we are right on time. How much is the time? Oh, 9:11. Oh, 9:11 is the time. So great. Behind Lovable. Cool. I'm sure many of you might have gone ahead and tried your hands or at least heard about these apps, like these very high growth apps called as Lovable, Bolt, Emergent, V0. What they do is you give them a prompt, then they work in the back end in order to create a full-fledged application for you. Right? What these apps do at the back end is something that I'm going to tell you today. Okay. I'll tell you at a high level how these things are supposed to work. But before that, we should follow the rules. Okay. The first thing is, what is the user value? The user value here is that as an entrepreneur, as a product manager, as an engineer, I either do not know how to code or I do not have enough time to spend on an unproven idea. So what I do is I give it a prompt. I want a tool that can help me build a full-fledged app that can help me test my idea. Before these kind of apps, before AI, what used to happen, I will hire a developer, I'll build something, and then it will take me a lot of time, then it will take me a lot of money, and then maybe I'll know that this thing is not working. Right? Why? Because you only know if a product is working when you go ahead and launch it. So it was very difficult to build full-fledged apps without the involvement of a developer. These no-code tools that used to happen before that, like Webflow and all, they were not very effective for any non-engineer. They still used to take a lot of time. So now with the possibility of AI, we have some tools with which we can just go ahead and give it a prompt. It will be able to go ahead and generate a full website or an app, right? So value unlock is definitely there. Okay. But you should define what is the market that you are playing in. Is it engineers or hobbyists or entrepreneurs or non-coders? That will define the UI and the UX, right? And the strategy. Why should the business pursue this opportunity? There are so many people who want to build their own products, right? And traditionally, these people do not have the power to do this. Why? Because technology could not support it. Now, what has happened right now is that there is a technology called as GenAI, through which this is possible now. Okay, so now there is a huge business opportunity out there. You can do the sizing of the market in terms of TAM, SAM, SOM, but there is a big market opportunity, right? And many product managers, many entrepreneurs, they want to build quick prototypes before they can go ahead and full-fledged take the business, the engineering resources. There is a business value. The third part is design. How do we make it intuitive to use? So if you look at the platforms such as Lovable, you'll be able to find multiple things. Okay, first is these platforms give you a very good interface where you can just write a prompt like a chat. Plus, they will let you to add any screenshots. So most of the people, they are inspired. So they will go to a website, look at the website, it is looking good. They will take a screenshot and they want to make something like that, right? And then they are also going to give you examples of how other people have done this. So you are getting some inspiration. Okay. Plus, they also make sure that there is a community which can go ahead and help you. So you can go ahead and get added to this community. And then you can go ahead and learn about how other people are using Lovable. So it makes sure that you are able to get onboarded on the platform very, very easily. Right. And then they also have some learning tutorials and all that make sure that it is easier for you to use. And they have also made sure that they have a free pricing plan. Yes, I already have a paid plan. So they do have a freemium plan through which you can go ahead and try the platform before you go ahead and start spending your money. Right. So this makes sure that the platform is usable. The ultimate usability is coming from the simple fact that an LLM can allow you to generate, like convert your simple prompt into a full-fledged website or a web app. Okay. So this is the usability. And then how does it work? Okay. How does it work? So this is the simple architecture of these kind of apps. Okay. The user will give the input. Okay. The user will give an input that please create a clone for Airbnb. Simple. But they are going to enhance it with a system prompt. So they will write a prompt like, you are a senior level system architect and a backend developer and a front-end or a full stack developer. And now you have to create the app, the product that the user is requesting. Make sure that you are going ahead and following up with, all the engineering principles and using these kind of files, and they would go ahead and give more context. Okay. So your prompt, whatever you are giving, will be enhanced with the system prompt. And then as a result, what you will have, first, it will create a prompt to plan the whole product. Step number 1 is create this file. Step number 2 is create this file. Step number 3 is create this function. Then create an API. So it is going to lay down the complete plan. After that, it will create files. It has access to a virtual environment. So now it is becoming agentic. Why? It has an access to a tool. What is the tool? The tool is a virtual environment. So what will happen? A virtual environment is nothing. A piece of computer that is given to Lovable, where it can go ahead and deploy your apps. Okay. So it has access to a file system. It has access to an automatic deployment. Okay. And then it is going to keep on running the file on itself so that it is able to understand if there are any kind of mistakes. And then because it's an agent, it is going to automatically correct these mistakes. And eventually you are going to get the output. Okay. So Lovable, Emergent, V0 are nothing. They are just agents which work in a loop to correct the mistakes. And they also make sure that they have access to some kind of file system where they can host these files so that you as a user can go ahead and access these files. Okay. So let me give you a moment. Okay. This is ChatGPT. I am giving a simple prompt to ChatGPT. Okay. I want to create a clone of, okay, help me create a system prompt that I can use in my vibe coding app, where user can enter their idea of app and the system prompt will make it detailed, effective, to be able to create a dependable modern app with, let's say, JavaScript as the primary language. Most of the apps you will see that they are written in JavaScript. Okay. I'll just click on this and then I'll get a very detailed system prompt. Yes. So here what will happen? While the prompt is being generated, what will happen here? I will create a system. If I want to create a clone of Lovable, I will create a system. This is the box. User will input something. This request will be added with my system prompt. And the user input will be added. And then it will be sent to an LLM. And then I'll get the complete set of instructions. Right? So this prompt I have taken. Now this is a prompt. System prompt this. You are a vibe coder, this, and now you understand everything is mentioned here. Right? This now will be sent to the LLM. Now, based on this, files would be generated. So it will create a plan. In the plan, there would be some files, there would be some testing, there would be some functionality. And then this will be again sent to the prompt. Right? You can actually create your own Lovable, your own emergent with the help of Relay app, because there also you are executing instructions step by step. Right? So this is how Lovable and every platform works on the backend. So agent is nothing. It is thinking and accessing tools in a loop. So they have orchestrated them in such a way that they are able to go ahead and execute things again and again in a methodical or a stepwise manner. Right? Now, agents are built on multiple patterns. One pattern is that there is one agent who is doing multiple tasks. Then, let's say if I give you people an assignment that tomorrow you have to create a case study on Lovable. 5 people in the same team. Okay. Now, what will happen? I believe that if 5 people are working on the same team, the quality should improve. That is why I'm putting 5 people. And I'm giving you less time. For an individual, I would have given 1 week, but for 5 people, I'm giving 2 days. So now, because I think that efficiency will increase. So now what you guys will do is, you will divide the work among yourself. That I will do the research, you do the drag, someone is going to do the design, someone is going to do something else. Okay. And when you go ahead and come back, you are going to go ahead and combine all the outputs, and then you are going to create something which is a one case study. So this is how agents also do the orchestration. So there is also design patterns in agents which define how different agents are going to work with each other. Okay. So this is in a nutshell what agents are. Okay. Everyone tell me on a scale of 1 to 5 are able to understand agents. Yes. So please, everyone, please understand things from first principles, which is agent is nothing. Agent did not exist. AI agent did not exist 4 years ago. Okay. So it's very simple. If you are creating a workflow which can have an AI LLM in between, which can execute actions for you and do some intelligent task, that is an AI agent. Right? Now, after this, there is one problem with the agents. The problem is that the agents, in order to act, they need to connect with tools. LinkedIn is one platform. Gmail is one platform. Google Drive is one platform. Maybe your SMS is one platform. Your Telegram is one platform. And there are so many platforms. Your Slack is one platform. So they need to connect with many tools. And if you are someone who is building agents where LLM needs to connect with the agents, with the tools, then it's a nightmare to read every API and connect your product with the API. Okay, so if so many, let's say, like one LLM has to connect with multiple products, then everyone has their unique API. So that is a nightmare. So now what these people have done is, Anthropic, the people behind Claude, they have created a simple thing, which is they told everyone that if you want to, they have told Gmail, Slack, Jira, everyone in the whole world, that if anyone wants the LLM to use their APIs, please go ahead and create something called as Model Context Protocol, or MCP. So what is an MCP? MCP is, these people have created one more versions of their APIs or a layer over their APIs, which can be understood by large language models. Right? So maybe yesterday only, or a couple of days before, Zomato has launched their own MCP. So Zomato is an Indian website where you can, is an Indian app or website where you can go ahead and order food. So this is the detailed article on the same. Where is that? Yes. So now you can go ahead and do so many things from your Claude. So on your Claude desktop or your ChatGPT desktop, you can go ahead and install this Claude, this Zomato MCP, and then you should be able to go ahead and write these kind of queries. Indian food near Indranagar, pizza under 200 rupees, and then you should be able to make an order from there only. Right? So now Zomato has an API which already existed for a long period of time, but you cannot have conversation with an API through the LLM through natural language. Now they have created an MCP. What does an MCP do? MCP converts the natural language, helps the LLM to talk with the API in natural language. Right? That is an MCP. Okay. And there are multiple, I'll share this link with you so that you are able to go ahead and understand how it is created. Understand? It's not difficult to create MCP. What you need to do is, if you are a product like Zomato or any other product in the world, you would have an API documentation. Take that API documentation, go to ChatGPT and ask it to convert into an MCP. It will give you a file that you have to host on your server, and then you are done. You have to do a couple of testing as well, but that is done. right? So that is model context protocol. So in model context protocol, we have three components. The first part is the AI host, where you are going to send query. So it could be Claude, Cursor, ChatGPT. This is where your MCP client is going to be there. This is your MCP client. Okay. Then there is an MCP server that is hosted at the person who has given you the MCP, which is Zomato or Razorpay or something. And then there is the data source. This is stored at Zomato or something where you can go ahead and have the data or you can take actions. Okay. So any MCP server will give you a small file that is called as client configuration file. You have to enter it into your Claude or any of the LLM that you are using. And then your agent will be able to talk to these tools without understanding the API. Right? So this is MCP. You can go ahead and read more about it. Right? Yes. So we have talked about so many things so far. Cool. Everyone tell me, how would you describe the session so far in one word so that I know if we are going in the right direction? Tell me, how would you explain this session so far in one word so that I can go ahead and tell you something more. Yes. Great. Now let me just go ahead. Thank you. Thank you, everyone. Thank you for the nice words. Now I think we are on time. So we have some more time. So I'll give you one more thing, okay? Which is evaluations. Look at this very carefully, okay? So there are some challenges that happen in building AI products. The challenges are they hallucinate, they have certain kind of biases, and they are indeterministic. Okay, but understand, nowadays you people would be understanding that language models are becoming more and more intelligent. Okay, if you find that there is an error, you can ask it to correct that error and it corrects that error. Okay, but still, large language models are these powerful beasts. If you leave them without a leash, then they can do a lot of disaster to your customers. Okay, so this is what AI believes like. Okay, it believes that it has all the content in the world and it can give answers like wrong answers with complete confidence. Okay, so that is why we have something to tame these beasts. The leash that works on your LLMs is called as evaluations. Okay, and what happens is whenever your LLM is not working and if you're not getting the right kind of output, there are certain issues and you can resolve these issues with three things. Okay, so when you are building any kind of GenAI product, you have to take three important decisions. The one important decision is what is the model that you are going to choose. If you choose a very high quality model, then you have to pay more cost. If you choose a very low cost model, then you have the issue of accuracy, right? Similarly, RAG instrumentation. In RAG, there are multiple components. If your chunk size is not correct, then the information that it is giving you would be incorrect. If you understand, I have told you that there is a vector embedding. But for vector embedding also, there are multiple algorithms. Which algorithm should you use? Okay, it depends on the use case. So what is going to be the instrumentation of your RAG? What is the vector algorithm? What is the size of chunking? What are the different kind of model that you will use? That is also very important. Okay, these are the decisions that you need to take. And then context engineering. What should be the prompt? How long should be the context? How you should give the instructions? These things are going to determine whether your GenAI app is working rightly or not. And this is actually engineering. Engineering, why? Because there is going to be a lot of course correction. Okay, so in order to do these things, in order to understand whether our GenAI application is working well or not, we have something called as evaluations. So what evaluations do is they check the output for correct syntax and formats, for bias, for correctness, relevance, and other unnecessary checks. Okay, so for example, if on Notebook LM or if on Granular, we generated a summary, we want to understand whether this summary is actually aligned with whatever is being said in the meeting or not. So how do we test this? We test this with the help of large language models. Okay, so what we do is, to help you understand evals, I'm going to give you a case study on the AI First job website. Okay, so tell me in the chat how many people are looking for jobs. Tell me in the chat yes or no if you're looking for a job. Yes, guys, even if you don't know, your colleagues and your bosses might be present in this meeting. Now, I will give you an idea, okay? And I'm sure many people would have faced this. Okay, so let's say I am creating a new kind of job website where what I'll do is I will crawl all the websites from the all I will crawl all the jobs from major websites from the internet. So I'll go to Hired, I'll go to LinkedIn, I'll go to Naukri, I'll go to InstaHire, I'll go to multiple websites, I'll go to Indeed and other websites in order to crawl jobs. Crawl as in I will go to this website automatically. I will get the content and I'll scrape the jobs. So now I have a job database. I have database of all the job descriptions, titles, companies, and everything. Right. Now what I'll do is I will enhance this job with LLM. I will enhance this job with LLM. And by enhancing, what I mean is I will give it a prompt. And then what I'll do is I will generate this output. So I will enter a job description. And then the LLM will give me summary of the job description, possible interview questions. So from the job description in the company, it will try to understand what are the questions that can be asked, skills that are needed to do this job, learning guide for this job, and quiz for assessment, which is a small quiz that will help me understand whether I'm ready to fill or apply for this job or not. Okay, this is a simple website that I need to create. Okay, tell me everyone, will this kind of website will be helpful for you or not? People are looking for jobs. Yes, so it will give you some more context about the job description. Right? So now, and this can be created. You can go ahead and create this website today also, like by using Lovable or something. Okay. But now there is an issue. How do I know this job description, interview question, skill needed, learning guide, everything is good or not? Okay. So I'm going to introduce one method of, so understand these things that I've told you, which is all of these things, they are done with multiple methods. One of the method to run your evaluations is called as LLM as a judge. So we run our outputs through another more intelligent LLM in order to understand whether it is correct output or not. Okay. So here the issue is that although I'm generating good information, but this information can be wrong. Okay. So what I'll do is I'll do this. Okay. So I have crawled the job from the internet. I have stored them in my database. I have ran them through LLMs. And then I have created this content. I have created this content. Now, what I'll do is I will get all of these things, again go through another LLM in order to understand, which is called as evaluation, that whether this content is correctly created or not. This is called as LLM as a judge. And then I will find out whether the content is correct or not. This is a simple method of evaluation. Let me show you how it works. Yes. So this is the evaluation. Look at this very carefully, guys. This is the prompt that I'll give to the another LLM. Okay. You are an AI content quality evaluator for product management job listings. Given the following, this is the original job description. This is the AI generated summary. This is the interview question. This is the output from the other LLM, right? These are the skills. These are the concept. This is the quiz. Evaluate the content using the following checklist. Is the summary accurate? Interview questions correct? Listed skills aligned? Are the concept useful? Is the quiz challenging? Is any information correct or hallucinating? And then give me the response in this particular format. Okay, then I'll have a dashboard where for every job description, this score would be mentioned. Then I would know whether my LLM is working correctly or not. Okay, so let's say if I get poor or fair or low or weak, what I'll do is I will go back. I will again try to tweak these things. If my quality is bad, then I will maybe change the model, or I'll change the RAG instrumentation, or I'll go ahead and change the context engineering, which is the prompt that I have given. Okay, that is how you improve upon AI product with the help of evaluation. This is a super simplistic example of evaluations. Okay, there are code-based evaluations as well. There are LLM-based evaluations as well. Generally, this evaluation LLM that you use, so this is LLM1 and this is LLM2. This LLM is generally a more intelligent LLM which is able to assess, right? So this is an example of evaluation. Everyone, a quick yes or no if you are able to understand this. Yes. There are many open source LLM, guys. OpenAI OSS is an open source LLM. Llama is an open source LLM, right? So this is there. Now we have almost completed the session. This is some set of tools. If you guys are curious, you can go ahead and start using this in your product management workflow. There is also a detailed video on this on our YouTube channel. Okay. AI for PM's toolkit, discovery for discovering what to build, Chat GPT, Notebook LM, Perplexity, Mixpanel, Text to SQL. Okay. For delivering Atlassian intelligence, which is nothing but Jira, Asana, V0, Cursor, Postbot, Figma, which you can use to create wireframes, prototypes very quickly. Okay. And then for distribution, you have Craftful, Chatbase, Notion, Gendex, MoEngage that can help you create marketing materials, collaborate with your team, and look at analytics. Okay. So try to explore these tools at your own time so that you are able to become an AI enabled PM as well. Whatever we have discussed so far was for AI, like applied AI PM. Right. And then one more important thing, guys, that in this program, like so far, what I have done is I have given you information. I have given you information about evaluations, about agents, about various tools, about RAG, about prompt engineering, about fine tuning. But information is not helpful for you. Information is just a couple of prompts away. What you need is knowledge. And how do you convert information into knowledge? With the help of action and with the help of feedback and reflection. Right? So what you need to do is, please do not limit yourself to only this knowledge. Go ahead and do something. Doing as in, go ahead and build something. Okay, you have so much information available across the internet. Utilize and try to go ahead and build something. Right? If you guys are looking for mentorship, then we also have a very detailed program. So understand whatever I have told you in this last two sessions, that is not even 10% of what we teach in our bigger program. So if you really found this information genuine useful, I teach a bigger program, which is a 15-week program on AI product management. Okay, you can go to the website, you can get all the details out there. But if you have to ask me, let's say 3 reasons why you should join HelloPM program against other programs is very simple. First, it is the most detailed AI product management program. We first talk about the traditional product management, then we talk about AI product management. You can go to the website, you can compare the curriculum, you can compare curriculum to any other course in the world. You will not be able to find a more detailed program. First point. Second point is everything is practical. We believe in doing things. So in the end of the program, you are actually going to go ahead and build your own product. Okay, so if you go ahead and go to the website, if you go ahead and go to the website hellopm.co, you should be able to find in the curriculum section that this is the whole curriculum. Everything is supported with a lot of case studies and tools. Plus, in the end of the sessions, we are also going to help you build your own AI product. This helps you prove to other people and to yourself that you are not an information seeker. You are actually someone who understands how to build products. And this is a big opportunity for you, right? And we also help you prepare for interviews and all. That is given. And then, yes. And then the third part is, we are the only program that supports you for the long term. Even if you have completed the program, we understand that some people are able to get the job within the program. Some people get the job after the program. We support you for a period of 2 years. So in these 2 years, if you have any questions, any feedback, anything that you want to get help from us, you should be able to talk to us. Okay. And every week we keep on doing sessions to make sure that you are able to learn. Okay. Yes. Yes. And you can go to the website in order to check all the other details that are out there. The cost of the program stands at 75,000 rupees or $1,000 if you are outside from India. Okay, but it is my assurance that if you go ahead and take this program, this is going to go ahead and give you a lot of content. Right? We don't give any kind of discounts, but this is the context. If you want to get more information about this cohort, just go to the website hellopm.co and then click on this video. You should be able to get all the information. Right? Now, an important part. Okay, that is why I've given you this context. Yes. Classes are conducted on Saturday and Sunday, evening 8:30 to 10:30 for IST and morning for the US batches. Okay. So now everyone understand, if you really want to get into AI product management, you have to build a strong portfolio so that people understand that you have what it takes. Okay. You are actually not a talker, but a doer. Okay. So what you should do is, in order to create a portfolio, you can start very small. Start by commenting and start by creating content about GenAI. Understand for yourself. Okay. Then do tear down in case studies. Then do product improvements and go ahead and build some, like try to go ahead and build some hypothesis of the products. After that, build some side projects. And then if you have already done some past work, you can include all of these things and then you can use in your portfolio. You can go to the HelloPM channel. There we have created. So if you go to the HelloPM channel on YouTube, we have an amazing playlist called as Summer of Product. Okay, or this is the playlist, Getting Started with Product Management or Summer of Product, where I've explained how to create a portfolio. Okay, and then the last part is this. This is the most important slide. What you should do is, please do not limit this information that I have told you so far to just this session. Okay, don't forget about everything as soon as you leave the session. Please take action. What you should do is reverse engineer top AI products in the same way that I have told you. Understand gaps, frustrations in your personal and professional workflow. Build AI tools and agents to solve these problems. Start writing what you are learning. Tag me, I'll be able to like and post and repost, right? And then keep a track of AI companies, what they are doing. Help them improve, enhance, expand, and then follow up. Try to find companies who are really doing good. And then understand their product, reverse engineer the product, suggest improvements, reach out to the founders, and then follow with the founders. Most of the time, you are going to get some appreciation, attention, and maybe a job. Okay. There are many people that we have helped came from completely non-tech background, some senior background, some junior background, and they were able to become product managers. You can go ahead and look at this playlist called as Transition to Product Management, where you can read their stories. Okay. So this is it about today's session, guys. Yes. The flagship program is 4 weeks of foundation PM content, which is strategy and product sense. 8 weeks of going ahead and creating, like understanding AI in detail. So understand, if I can give you this much information in 2 days, what can I do in 8 weeks or maybe 15 weeks? And then there are 3 weeks of building your own product. So flagship program covers the entire AI PM syllabus. If some of you wants to check how does a HelloPM cohort looks like, let me show you something. Give me a moment. Yes. I have shared a link in the chat. This is the detailed video where we have shared the kickstarting call for a cohort. So at HelloPM, we try to keep things as transparent as possible. We love that. We love being honest in this really corrupted edtech world. So I have gone ahead and shared a link where you can understand who are the kind of people who join, what are their backgrounds, so that you are able to go ahead and take a better call. Yes, and there is a lot of free content that is available on our YouTube channel. You guys should absolutely go ahead and check it out. The placement support that we offer is including 4 things. We help you create a better resume. We help you build a strong portfolio. We help you prepare better for the interviews. And then we also have an internal job board where alumni, our network companies, and other companies that we seek out to also list their jobs. And for many of these jobs, referrals and recommendations might also be available. We do not guarantee placements, but we help you out in all the possible ways that we can. And we also are available across the globes. So we have a lot of people who are going to join from UK, from the US, from Canada, Australia, New Zealand, and as well from India. And this happens because of a large alumni network that we have created. You can use self-hosted in LLMs without having internet, but you should have a powerful computer. Cool. Thank you, everyone. I'll just go ahead and end the session now. Thanks a lot for choosing to spend your weekend with me and with HelloPM. I believe I was able to go ahead and add some kind of value as available from the feedback and the LinkedIn comments. We are very soon going to conduct more sessions. The next batch is going to start from 9th of November. So take your time. Understand, you do not have to take this decision in FOMO. Go ahead, take the right decision. And understand it is not just a time investment. It is not just a money investment, but it's an important time investment. Okay. So take your decision by understanding everything. We want you to win. But once you come in the session, we make sure that you are working hard. Yes. Cool. Yes, everyone. If you have any custom questions, you can go to the website. There's a scheduling call link. You can go ahead and schedule a call, and then the team should be able to help. And we keep on doing these counseling sessions so that you can ask your questions as well. Okay, cool. Yes. Cool. Thank you, everyone. Thank you, everyone. Bye. Take care. You have been a great audience. Thanks again for choosing to spend your time with me. I really feel good that I was able to be somewhat helpful for you guys. Thank you, everyone. Bye and take care. It was my pleasure hosting you guys. Thank you, guys. Take care.